Okay. So we are set. Perfect. That's good.
So we're set, right?
So I'm going to the other one. Do you know how that works? Like if 10 minutes, they should finish, like get out of here and or finish the workshop 5 minutes before.
Yeah, but that's the workshop.
Yeah, but after there is another session. So
The flag.
you will show 10 minutes, 5 minutes, blah blah blah. 5 minutes before or 10 minutes before.
I didn't know.
Then they can make a. They can make a
Q&A, I guess, for 5
break
minutes.
if they want in the middle. And there were 9 drives, which I already distributed to this guy. He was copying the files that the people should have because the Wi-Fi is so slow that it's not available to them. So you just make sure that you collect 9 pen drives.
There were 9 total, right?
Yeah, 2 they are probably screwed up. So where they are. So 7 working. Okay,
Maybe
try
those?
to separate.
We have more USB sticks if anyone needs them.
Yeah.
Who just came in? Who opened a laptop and hasn't heard that you need
the black
those
one
OC client
and
tools?
The black ones are
Just
dead
him?
ones,
What about
right?
that gentleman there, the volunteer shirt?
I think the black ones are the ones who are completely crap. Okay, the black
Harrison,
one. Ask
interrupt.
this guy because this guy was copying it and he really. By the way,
They were black ones, right? Or they're of a different color?
sorry, there were a black one and a blue one. This microphone is working because the setting
You need
is
to
running,
recompile a new kernel, then you need to load a special network driver.
Okay, so this is working.
And for Windows, you actually have to contact Russia, get the hack codes, break
You
into
don't
the
need to do
source
anything,
code,
it's already
recompile it
done.
yourself.
So I'm going to the other room.
Exactly.
Okay, thank you.
All right, let's get started. We are 1 minute over.
Calm down. People are going to come. We have 3 hours.
We are 1 minute over, so it's time to get started. So, welcome everybody. My name is Grant Shipley, and this is Stephen Pousty, otherwise known as the Steve-O. I hope you were expecting a hands-on lab/workshop today. That is what we're going to be doing. Everyone should have their own machine, or look off of your neighbor's machine, or you could perhaps actually do all of this on your phone if you wanted to. Just don't use the command line tools, use the web interface instead. But if you do it that way, you're on your own, but we can walk you through it. So Steve's going to run through the slides at the beginning to introduce you to what we're going to be doing today. Yeah. Windows is fine. Look at this. Look at this, kids. I'm using Windows.
Do you know what I want? And I'm using it too, or at least the laptop I brought is. Do you want to know why Grant and I use Windows? Yes? Even though I prefer Fedora, it's because if you look at there's OpenShift Online? If you look at the percentage of Windows users on OpenShift Online, which is what we mostly advocate, it's about 85% Windows users. So we actually use Windows so that, look, surprise, surprise, most of the engineers on OpenShift do not use Windows. So to really get the testing done and to try patterns out, we use Windows as well.
Yeah, so it's I've started to like Windows a little bit, but I've been using it for the last year and a half, something like that. But it's mainly just to make sure OpenShift works well on Windows. It is my daily operating system now, even though I've been using Linux for the last 14 years or so. I have switched to Windows.
How do you play Battlefield on Linux?
We don't. That's the other reason why both he and I use Windows. We weren't going to say anything about that. I'll put my Division handle in here, and I'll also put my Overwatch handle in there as well.
All right, so I'm going to run through the labs later. I'm going to be kind of the lead for that portion. They should work. I was up till 1 o'clock last night running through them again just to make sure that there wouldn't be any problems. And Steve is going to run through the slides at the beginning. So with that, I will shut up. Oh, one last thing. If we talk too fast or not loud enough, just let us know and we'll slow down. Sometimes we just start talking and we start talking really fast and we think everyone can understand us, but sometimes they actually can't. So if we start talking really fast, just let us know and we'll slow down. All right.
The other thing is, Grant and I both like questions. Actually, for that man interrupting Grant while he was speaking, which is rare for most audiences outside of the U.S., he gets a free coffee card. So we encourage, there's 5 more coffee cards. I saw everybody looking longingly at the coffee cards. For good questions, not questions like, can I have a coffee card? We'll give out some more coffee cards as well, okay? So this is the deck right here. This bit.ly link at the bottom is actually the deck. I recommend you actually open it because there's links to some of the others, like there's links to the tutorial doc in there. There's links to other things in there. And you can follow along on that as you want as well. It's bit.ly/DevConf W for workshop, not Windows. Okay?
It will stay active even on.
It's a Google slide deck. Oh, and it's also Creatively Commons licensed. So if you love, which of course you will, love this whole workshop and you want to bring it home and then show it to other people, you can, and just take some of the slides out, go for it. Just it's attribution only, okay? Although I don't know what we're going to do with we'll probably repoint. Can you make it into a PDF or host it somewhere permanently? Okay. So goals, there's really only one goal here. It's an introduction to OpenShift and how to use it to build and deploy your applications. Right? There's not many other goals than that. And I'm assuming that aligns with what everybody here wants. Is that pretty much what people were expecting? Have any of you started using OpenShift v3 yet? Okay, so you're probably going to be bored. Have you actually done development with it? Okay, no? Yes? That was something. You've done something with it? That's really good.
We don't learn the security feature.
What?
We do.
I know. But in general, you might be bored, but for everybody else, it should be good. Here's the notes for the workshop. Don't click and read those yet. I see everybody getting ready. When we get to the workshop, you can click on those and start doing them, but that's where they'll be later when we do it. Ground rules, ask questions and interrupt us. The other thing is workshops to me are not the sit and do exactly what we said to do. That's actually because you've already seen it. I'd like you to actually play around. Like once you've done the basic thing, we'll give you enough time to actually well, I wonder if I can point that at my own Git repo. Oh, I wonder what happens if I try this. And try things in the class. There is 1, 2, 3, 4, 5, 6, 7 OpenShift either engineers or advocates in the room. So we're here to help you figure stuff out. It's not just to sit and listen to us talk about slides or to read a PDF or a document, because you can do that at home. Okay? If you don't have the clients, there's the link to the client tools. Okay? But everybody should have them because we gave them on the USB stick. Today's stack. Oh, so how many here have used Docker? I'm assuming everybody, yeah? Have tried it at least? Is there anybody who hasn't? Let me publicly shame you. Okay, great. No, just kidding. I'm not going to shame you. We're not going to talk too much about Docker today. We can talk I'm going to talk a little bit in the beginning, but we're not going to go into detail much about Docker. And it turns out with OpenShift, as an application developer, you don't even really have to know Docker that much. It's not low-level Docker commands. How many of you are app devs or develop applications? The rest of you sysadmins? QE? Sysadmin. What are they, like a quarter of the hands didn't go up. What do you guys do?
Manager.
No wonder you don't have a laptop. Okay. Who else? What are some other things? That's it? You just were shy and didn't want to raise your hand? Yeah. Oh, you're at Red Hat. You want to say what you do, though, anyway?
I'm a customer now.
You are a customer now? You left Red Hat? When? Oh, that's right. I saw the email. I just forgotten. Thanks for reminding me. Yeah?
Yeah, just about the Docker.
Yeah.
Well, being an app developer, that's exactly the shit I don't want to deal with.
Exactly.
So
that's why you're here.
that's why I don't know what a Docker is.
But I'll explain it. Don't worry.
Cool.
But we're not going to go in depth on Docker. All right. So then the next thing is Kubernetes. How many of you have heard of Kubernetes? Everybody? I'll go over it just a little bit. But the idea is OpenShift is actually a Kubernetes distribution. I know our marketing people don't like us saying that, but I'll explain why it is in a little bit, at least from my perspective. And then most of what we're going to be doing is OpenShift. So containers. In this case, we're going to be working with Docker containers. Containers actually everybody else, you can correct me when I get everything wrong. How's that? All right, just fact check me while I'm explaining to the 3 people. So basically, containers are not VMs. So a VM, you have to boot the entire operating system, right? With a container, what you're doing is you're taking the operating system and making slices out of it. They all share the same kernel. So the thing that matters is there's a kernel, and then you using a whole bunch of Linux black magic, they basically make slices out of the kernel. Is that yes?
How about the network adapter, for instance? Because using the virtual machines,
They're sharing the network. Go ahead.
yeah, I usually have the problem of sharing the one network adapter, so then only one web server can be on like port 80.
No, that is not the problem here.
So it's not a problem here.
Unless you were, we'll get to it later. It's not necessarily a problem. Usually what you do is each container will start up on their own port, and then you'll redirect from 80 to whichever one you want to redirect to. But there is only one external 80, right? Because there's only one physical hard.
Yeah, but it's still just, it's not like one virtual machine would occupy it and the others wouldn't be able to.
Can anybody fact check me on that one?
On the network,
That is not true with Docker, right? Yeah, okay.
well, on the networking side, essentially you do network namespaces, so each container has a separate namespace. You have
That's
a
right.
separate TCP/IP stack, you have a separate IP address per container.
Each container gets its own IP address.
And-
But
Like,
let's keep going.
Never mind.
It's not important to what we're doing today.
Thank you.
It would be a great Google search for you to follow up and read more material on later.
But hang on, as part of OpenShift, we actually include an overlay network, so you don't have to worry about that stuff.
coming later.
But that's exactly why we do it, so you don't have to worry about it.
Okay.
Right.
Yeah, that's why I'm sitting here.
Yeah.
Cool.
Okay, so the other thing is, it has, in general, it uses what's called a union file system. Who knows where union file systems came from? This is showing your age. So anybody under the age probably of 25 does not know what a union file system is. If you are older, you have definitely used it. Yeah, go. You were going to say where it's from?
I write on my CD drive with the
Exactly. It's a CD. It was originally designed as a CD drive format. CDRW. Does everybody remember? You could burn CDs, and you could burn multiple times to the same CD, right? And so that's what it's a layered file system. So you'll notice in what would happen in terms of a container, there's the kernel it's shared. When you start to write an image, though, you're writing everything in layers. So you can, in this one, all they did was put a BusyBox image in, and then everything else spins up on its regular space. In this one, they put Debian in, then they added Emacs, and they added Apache, and then the top on top of that is writable. And this is important especially in terms of compared to VMs, because you can actually have images inherit from each other. So you can have a base image, and then you can say, based on that base image, I want these following things. And then the next person, so then if I need to patch stuff, I can patch the base image and then rebuild the others, and they all pick up all the patches.
Can you also override files?
No. You can so it's just like a CDR. Once you wrote to that, do you ever use a CDR? You're in the age group, which I don't.
No, well, yes, but you could actually override files.
In a CDRW, that acted more like a hard drive, right? But with CDRs, you would burn, and then you would burn. You know, like there was the R's and the RWs. You would burn, and then you'd be like garbage, right? Because you can't put anything more on it. So it's like that. It's not an RW where you could clear the space and then write over it again.
Okay.
The nice part about it, so how many of you have seen Dan Walsh here? Or talked to Dan Walsh, or saw one of Dan's talks? So at the very first DockerCon, I helped drive the keynote demo for the VP who was talking, and Dan was there as well, because he was working on Docker at that point. And Dan said, I don't care about all this other stuff. The real reason I'm excited about containers is because we can finally get rid of RPMs. That was his big motivation at the time. He was super excited about it. Don't tell him I said that, though. But the reason why is because with RPMs, right, what do we put on the machine when we do an RPM? We put the bits on. With a Docker container, you're putting on the bits and how it's supposed to be configured as well. So you can just start it. Like if you put Apache on with RPM, you can then say Apache run, but you can't set any real configuration, like here's my index.html, it's in this directory, all that other stuff. With a Docker container, you can actually do that, right? So
Can I create an RPM containing all my configuration files?
You can, right? But as a software distributor, you can't do that. You can make your own, a user can make their own RPM, right? But as a software distributor, I can't ship it pointing to in the same way that you can. You can put down configuration it makes a runnable image rather than just the bits down on your machine with configuration files. Do you see the difference?
No.
The reason, okay, we're not being videotaped, are we? No, good. So the reason is I was going to be the ugly American abroad that I said that I was like, I'm going to start making country jokes, and then I almost got in trouble in LinuxConf Australia. I know I'm not in Australia, and I know this crowd is different, but I'm not going to go there. So that was the whole, yeah. Sorry? Yeah, it's parameterized.
Right.
Okay, you, not for you. And then, just for terminology, a container is a running instance of an image, right? The big fact, though, that I think this is the important part for developers, especially who are ones coming off of VMs, is that they're compiled and immutable. So how many of those of you how many of you have used AWS with EC2 images, right? A Docker container is like an EC2 image, right? I think a lot of us with VMs are used to, I'll go in, I'll make a change. When I shut it down, that change is still there, or I put my content in and it's still there. That is not the case with a running Docker image. You go in, you update an HTML page, the image restarts, or you shut it down and bring it back, and it's all gone. Right? So you have to operate in a different manner with Docker images than you would with VMs. And I think that's one of the things that's kind of hard. If you haven't used Amazon especially, that's kind of hard for people to grasp. So that's all I think I'm going to talk about with Docker. Yeah, so I just saw how to build an image. This is the other so do you guys know that containers have been around forever? Really? So is that nobody's moving their heads. I'm going to count on let me see, who are the most forward people? The Spaniards will never talk. I've spoken Spain, and they never talk. Germans will talk. I don't know if Austrians inherit from Germans. So I'm looking to the Germans to actually, can you?
I'm German.
Yeah, I knew you, shocker. So what's an early container before Docker?
Change group?
Yeah, that's probably one of the oldest ones.
OpenVZ.
I don't know OpenVZ.
It is.
It is? All right, I don't know OpenVZ. That's fine. But probably the earliest is change root jails, right, from BSD land. That was a container. And if you come to the keynote tomorrow, we'll be talking about the history of containers as well. Dan Walsh will be there, and so will Mike McGrath. I think one of the things that made Docker so successful, there's a couple different things, but one is they built this nice compiling, you can write a plain text file, and that you can use that to specify how to compile your image. Right? And so it's very easy. So one of the things that's been good about that for Red Hat customers is most people find their Docker images where? Docker Hub. How much do you trust the images on Docker Hub? Not at all. You said yes? I don't want to be anywhere near your machines. Or actually I do if I want to go spam a bot network. So basically you have no idea what's actually, they'll have the file usually, right? They'll say this is how I compiled it, but you don't actually know if that's what they did, unless they have like an automated build and all that stuff. So but what will happen for sysadmins, especially for Red Hat customers, is they'll have the developer bring the Docker file to them, and they'll say, this is what I want. And then they'll say, okay, great. And then they'll use like a RHEL certified image as the base layer and then build all the other stuff on top. The developer doesn't care because they got what they wanted, but the sysadmin is happy because they know all the layers that went in and they control them more. So if you want to go look, you can look at what a Docker file is. They're immutable, so there's some links to some best practices. Any other questions about Docker? Because now I am really done with Docker. Okay. Is that enough for you?
Yes.
Okay.
Thank you.
Because we were going to hold up the entire class just for you until you understood it. So containers are not enough, though. So most of you have played with containers, right? And so you go there. This is what my experience was. Okay. Oh, that's cool. Look, I spun up Apache. Now what? Right? Like I built this nice little image. Now what? It felt to me very much as a developer like I had just moved to lightweight VMs. Like it was still all the same problems. How do I get this into production? How do I link a bunch of them together? How do I actually decide which machine it should go on and stuff like that? So that's where you need orchestration, scheduling, and isolation. And this is where Kubernetes comes in. So Kubernetes is an open source project out of Google. Everybody heard of Google? And so its purpose is to actually orchestrate, schedule, and do all the stuff that you actually want to do with containers past like just spinning one up on your desktop. Okay? So how about some history about it? It comes out of Borg and Omega. So Borg and Omega were how Google orchestrated their containers inside of Google itself. Everything inside of Google is basically containerized. How many of you have Gmail accounts? Okay, and the rest of you are lying. And then, so that means each of you has like 5 Gmail accounts probably. So if you think there's 6 billion people in the world, there's probably about 30 billion Gmail accounts that there are, right? And so when they launch Gmail, they're launching a container.
For each account?
For each time you open the web interface, that's a new container being launched. So this is probably 2 years old, this figure. Google launches about 7,000 containers a second, which is probably more than you'll ever do in a year, unless you're at a big company. Yeah?
Are we talking about Docker
No,
containers?
their own containers, right? Remember we said there's change root jails, there's LXC, there's all sorts of stuff. Like Google is the one who brought in kernel namespaces, wasn't it, Google? C groups, sorry. I knew it was one of those fancy Linux things that I like having there, but I know nothing about. So they were the one who brought in C groups, right? Because of all the container work that they did. So they launch about 7,000 a second, and right now it's being orchestrated with Borg and Omega. And so the next version that they did of this, though, they said, hey, we really want to open source this because 2 reasons. 1, we know we can get more innovation that way. 2, if everybody's using our open source technology, it's easier for us to hire engineers, right? The typical open source story. So they came to us, we were one of the early, Red Hat was one of the early collaborators on it. We were doing something similar at the time. If any of you were following that space that early on, it was called GearD. Because our original containers, OpenShift used to run containers, and they were called Gears, and this was GearD. And we looked at them, and they looked at us, and they're like, oh, we're doing basically the same thing, let's work together. So we have a whole bunch of engineers working basically on Kubernetes. And so for us, Kubernetes, I'm going to say it's not literally, okay, but you can think of Kubernetes as our new cloud kernel. All right, and what I mean for that is, does Red Hat own the Linux kernel? No card for you either. We do not own the Linux kernel, right? We're probably the second largest contributor. I don't remember, first, second, third, somewhere in the top 3 contributors, but we don't own it, right? And we push things back upstream into it. Do we just give you the Linux kernel, or do we build a whole distribution around it? Don't answer, because I don't want to embarrass you again. Do we just give you the kernel, or do we give you a whole distribution? Thank you. Because the kernel by itself is not really useful. So for us, with Kubernetes, our thought is that Kubernetes is our Linux kernel, except in the cloud space. We don't own it. We contribute all that we do upstream. We are the number 2 contributor to Kubernetes. Everything that we do, and Harrison's actually an engineer, and so is Mikhail. Mikhail, have you done any Kubernetes? Pat, have you done any? Yeah. So basically, most of the work is pushed upstream. All our work is eventually pushed upstream. Some things we try to push upstream, and Google says, no, we're going to do that. Right? So we don't control everything. But we also build a whole distribution around it to make it useful for you. We find...
They say that quite often.
What? They say that quite often. Yeah. Because they're Google. Right? Yeah. We won't get into that discussion here. But that's how we act. And so when do we ship a modified kernel? Or do we ship a normal Linux kernel? Is it a proprietary kernel that's different? No.
We have RHEL had a proprietary kernel.
Sorry?
So RHEL had a special kernel with Red Hat patches.
Yes, but we don't, it's nothing like, it's not like, what company do you work for? It's not like HPUX versus AIX, right? They all had Unix kernels, but they weren't compatible with each other. There's minor differences between us and the Ubuntu kernel, but usually the incompatibility is higher up, not at the kernel level. Right, Mikhail? Thank you. Gosh. Check. Okay. So now I know what category to start putting the check, because Marek does the exact same thing to me. So now I know start worrying to put the check people in. So our idea is, yeah.
I'm sorry, I was not listening. Did you say something about me?
Not at all, Marek. I don't even want to get you started. So my point with that though is, OpenShift is a straight Kubernetes cluster. Okay? So there's a command line tool for Kubernetes called kubectl. I call it kube control. You can actually use that against an installed Kubernetes OpenShift cluster. Right? We're actually we're building stuff on top of, not taking their stuff and making it different. Right? I just want to make that point clear with it. And then, so we're done with Kubernetes. I'm going to accept the political part about it. Now I'm going to show you what a cluster looks like. I'm going to go through this quickly. Why? Because did you come here to hear me talk about slides?
Yes.
Or really? You can come by the booth later and I'll talk to you for hours. I'm assuming that most of the other people came here because they actually wanted to do stuff with their hands and play with it. So, and plus, everybody has only so much information they can fill in their head. I don't want to fill you up now going over architecture, okay? But I'm going to cover the big points here. So one of the big things is Kubernetes puts its containers into pods, right? So with Docker, some of the restrictions on Docker is 2 containers cannot see the exact same file system, right? They can't share the exact same, they can't look at the same files of each other. They can mount disk, but one container cannot mount the disk of another container. A lot of things actually need that. Well, not a lot. Some things need that. The other thing is they can't talk over localhost. And some things expect to be able to talk over localhost to another thing. So you can put 2 containers in the same pod. And then so the pod is the atomic unit in Kubernetes or OpenShift. Does that make sense?
Well, it's more than 2, right?
It could be 1 to n. What?
You can put more than 2.
Okay, so what country are you from? Poland. That ruins my whole theory. Say you're from Germany or Austria. Yes, you can put 1 or more in the same pod. It's true. So one of the things that happens with the web developers is, because they're like, oh, it's on localhost, and they're seeing the same file system, and so they're talking really, and it's really tightly coupled, I'm going to want to put my web server and my database server in the same pod. And that is a big no-no. I mean, you can do it, but in general, you'll never want to do that. That's an anti-pattern. Because suppose you're sitting there and you're getting a lot of traffic, and your database is humming along just fine, but your web server's getting exhausted of connections. If you need to handle more connections and you spin up another pod, what have you also spun up besides another web server? Another database, right? And it's basically what you want to do is a pod should be only the things that can live and die together. So if you had a database and then you had something that was like monitoring the logs of a database, so it needed to see the file system, great, put that in the same pod. Because there's no reason for the monitor to live without the database itself. But if you need to scale things independently or they don't have to be together, put them in different pods. Sound good? Okay. So that's that. We'll get back to pods in a bit. What happens is there's 1 to n masters and 1 to n nodes in the cluster. The master and the node can be on the same machine if you want to. That's what we do with our all-in-one. But in general, for a real cluster, each master will be in its own VM, and each node will either be in its own VM or bare metal. This runs on VMs or in bare metal, wherever you want to run it, right? It just needs a machine. Does that make sense? And so the nodes are where all your pods live. It's where all the application stuff happens. The master is the part that takes care of what happens on the nodes, who goes where on the nodes, all that kind of stuff. Does that make sense so far? Okay. So the master, to talk to the master as either a sysadmin or a developer, you're talking through a REST API. And so when you're using our web interface today or our command line interface today, they're both talking to the same REST API. Does that make sense? So the great part about that is for systems administrators, if you want to automate something, you can also you can write Python, you can write any code that can talk to a REST API and automate those tasks against the same master. And with our command line tool, you can actually ask it to be really verbose, and then you can see the exact REST calls, and you can just copy those in your own code. Okay? There's a bunch of other stuff happening here, like auth, and the one I really want to talk about, though, is the data store. So in OpenShift, some of you said you've played with OpenShift. Do you know no Red Hat engineers are allowed to answer, or former Red Hat people? What is that data store in OpenShift? Does anybody know? Have any of you heard, Marek, stop talking on Slack because it's showing up on Grant's screen.
Yeah, let me fix that.
Oh, sorry.
It's etcd. Have you guys heard of etcd? It's a key value store built to be distributed, right? And it was built by CoreOS. And I can keep talking while the slides. Oh, you fixed it? Okay. So this is actually etcd here, the data store, and it's on all the masters. How many of you used OpenShift v2? A couple of you? Some of you? All the Red Hat people, please keep your hands down for these questions. They do not apply to you. what happened with V2 is when you made a request and you say, oh, I want to spin up Tomcat, let's just say. What it would do is it would go here to the master, and then the master would try to go find a node and then say to that node, hey, spin up a Tomcat cartridge for me, or a Tomcat container, and then it would wait and watch. And when this came back and said, oh yeah, I spun it up, then it would come back to the master, and the master would go and say, hey, yeah, I spun up your Tomcat container, and here's all the information about it. That is not what happens here. The way that Kubernetes works is what we call declarative syntax. It's a declarative cluster, right? What you basically are doing through here is setting up facts in the data store. And you can actually do this by submitting a whole JSON or YAML file. So you could say, I need 2 Postgres servers, I need 5 of these, there's an 5 web servers, an AMQ server, this is the facts. This is what I want the world to look like. Does that make sense? You say, okay, you feed it into the master. And then what happens is, all the nodes are constantly checking into the master saying, hey, does the world match the truth? If the world does not match the truth, we're going to make it so. The master never says to everybody else, hey, I've got some new information, go do this for me now. It's the cluster that comes in and says, I need to make sure that the cluster always matches the truth. Which makes it able for us to basically state a truth file and then have the cluster go do it. And this allows things like, if this whole node goes down, right, we've got this yellow, there's a Postgres, there's supposed to be 2 yellow Postgresses. Does everybody see that? The truth of the world is there's supposed to be 2 yellow Postgresses. If this node drops out of existence, the cluster is going to keep saying, how many Postgres instances am I supposed to have? 2. How many are in existence? 1. Okay, I need to reschedule and make another Postgres instance somewhere else on another node. Does that make sense? Which is awesome. So basically we get self-healing out of the box for free.
Does that mean that every node needs to talk with each other?
Yes. And is that handled by the kubelet? Do they talk to each other? All talk to each other, Michal?
No, they talk to master, and the master talks to them.
No, so they don't all talk to each other. Michal's smarter than me on this one. Okay, you've made up for yourself from before. And that's the kubelet that handles all that, right? The kubelet handles all that. The kubelet that lives here handles all the communication with the master.
Is an agent of the node that relay the information to master.
Okay.
And the kubelet also instructs Docker or container runtime, because I hit Docker, so container runtime to start the container.
Okay, so the kubelet is kind of the bridge between the two.
It's like broker
Between the master and actually getting stuff done. Okay. So, does everybody get that idea? Okay. The other thing that this handles is scheduling. So the idea, and what the scheduler is when you say, oh, well, I want to scale up from 2 to 3 of my web server, the master is the one who's going to decide which node are we going to try to put that on. Does that make, that's scheduling. And so what's nice about Kubernetes is it has rules for scheduling. And you can specify as many rules as you want and specify the order in which you want them to apply. So, for example, one thing that most people do in their rules, and I think this is the default rule, is non-affinity. So we right now have, let's see, we have these 2 yellow Postgres's. Let's say I scale up another Postgres. What this means, disaffinity means is, do not put it on this one, and do not put it on this one, because they already have a Postgres on them. Because if you're trying to build redundancy, you don't want the same thing to end up on the same node all the time, right? So then you can have another rule though. So we now have 1, 2, 3, 4 nodes that we still have to choose between. So you can have another rule which says least CPU. And it's going to go through those 4 and say, okay, this one only has Node.js and Couchbase on it. Those aren't pretty big CPU ones, so I'm going to schedule on that one. But you can specify least CPU, least memory, all sorts of other things. You can also set disaffinity between clusters. So you can say, or between data centers. Like what happens is, and we'll see this later, everything in Kubernetes happens with labels and selectors. And I'm not going to talk about them too much just yet. But you can label each of these as being in data center A, and then you can have a whole other set of nodes that are in data center B, and you can say, I want disaffinity at the data center level. So I'll spin up one here, then I'll spin one up in the other data center. that make sense? And there's nothing the sysadmin has to do with that other than set up the rule. Once that rule is set up, the cluster takes care of the rest of it. Yeah?
Maybe you finish, but afterwards maybe you want to talk a little bit about the truth and the reality of that stuff. Because back in the days I was starting my database, simply waiting for it, and then starting my web server, so the web server knows, oh, my database is up and operational. How's that happening? Is there a truth and a real truth and a reality? Or?
Oh, so if I understand your question correctly, it's you want to be able to say that the truth is the database has to come up first, and then you start up the web server. Is that what you're trying?
Come up first and be operational. So
It's ready to handle connections, and do not start the web server until that happens. So there are ways. I don't know. Do we handle that yet?
No, because that's coming to how you build your application. You should build web server in a way that will hold the code.
It's resistant to the database not being there, and then when it is there. So did you hear the answer?
yeah, I know,
The cluster doesn't handle that.
I'm German. I know the answer. But I think it's
So wait, so the other thing I need to add to my wait just before you get to the truth, I can talk to this just for a second, but also the new rule I need to add about Germans is they will ask you questions just to make you look bad.
no, that's not right. I just asked the question to make these people educate the right thing, right?
Yeah, so you can just say, hey, you should talk about it. You don't have to.
Yeah, right.
So there's one thing that you can do.
The answer is pretty important. You need to change your application for the new world. Right?
Yeah, we haven't even gotten that. There's a whole bunch of implications for this design in general that are not like, does everybody know the difference between microservices and monoliths? Right? Like you have one big bundled application. In this scenario, there's a whole bunch, this whole architecture is different. These pods are ephemeral. It's not like in the days when most of us grew up building apps and we had a whole server and we built our apps even though we knew it was false that, oh, I've got a box with redundant power supplies and RAID arrays, that database will always be there. And I can build my app assuming that database is always there. Even though that's not true, it was rare. In this situation, it's less true, more than before, that the database will always be there. Building on this kind of architecture means you cannot guarantee an IP is around, except for one thing and one thing only, which is a service. And we'll get to that in a bit. But you can't guarantee that thing is actually even up when you expect it to be up. So you have to rebuild it's about horizontal scaling. So the topic to read about is what's called horizontal scaling. You have to build your app so that it can horizontally scale.
So
Does that get to what you wanted to talk about? There are things you can also put, though. Can I just say my one thing, or do you want to say, are you going to talk about action hooks?
No, I was just thinking about this, and we don't obviously know everything about OpenShift. No person on the planet could, because it's a big system. But I was just thinking, in that scenario, why couldn't you, on your web front end, set a readiness check that points to the database, and
Yes.
then your apps wouldn't actually be really deployed until your database comes up? You would do it that way, I would think.
So most of the people here probably do not know what a readiness check is.
Yeah.
So there's the
We're gonna do
ability.
them in the lab.
It's coming in the lab, though, and we'll talk about it. But there is the ability in Kubernetes, and you guys will do this later today, to say, do not route traffic to this thing until this check passes. And so then what Grant was, does that make sense? Then that comes right in the platform. What Grant was saying is then actually write your web application code to query against the Kubernetes API, which you can do, to say, yeah, you could with an SA account, Graham, to say, do not start trying to connect to the data, do not come up until that indicates that it's ready. Is that what you were saying?
Yeah, with one.
But I want to get through the slides.
Okay. With one caveat, just so he's clear. He said change your application code. It's not your actual code. It's your configuration inside Kubernetes for the application. It has nothing to do with your actual source code.
Maybe.
Yeah.
Whatever. How can you be wearing all those jackets, too? Aren't you sweating?
No, I'm cool.
Oh, my God. She's killing me in here. Okay. So the main things I wanted to get from the architecture. We know what a pod is now, right? Please say yes so we can keep going. Okay, thank you. And we know that there's a master with nodes. We know that there's truth, and then the cluster trying to make the world match the... The other thing you could have fixed when you turned off Slack was your screen. Isn't it plugged in? Why is it...
I don't know. That's weird.
Maybe it's not really plugged
in.
It is Windows. Yeah, exactly. It's Windows. We've learned that. We learned about scheduling. We learned about the REST API. The last thing that I want to talk about in the architecture, and we'll talk about this in a second, is remember we said that you can't attach two containers to the same file space, but we also don't necessarily want to even attach to the file space on the machine itself, right? Because you might want to share it between different nodes. Kubernetes has plugins for persistent storage. Okay? So what that means is, as a system administrator, you can take a Ceph cluster and attach it to the entire cluster, and then each node can make claims into that cluster and get space. This could be iSCSI, it could be NFS, it could be Gluster, it could be Amazon EBS, it could be Google Storage Engine. So what's nice about that is the people writing the application code don't have to know what this is. They can just actually write their application and make a claim against the space, and it just works for them. Does that make sense?
Yes.
Yes. Thank you. Thank you. One of the other things that comes from OpenShift that doesn't come from Kubernetes, so these are the things that comes from OpenShift, not Kubernetes, is logging, metrics, and included Docker registry. So Kubernetes does not have an integrated Docker registry. Because we include a Docker registry inside of our cluster, we can actually do things that you'll be seeing later. It gives us a lot more power. And then the final thing that we do that doesn't come with, it's starting to come now from Kubernetes, is routing. So when a request is made to your app, actually how to route to the appropriate pod. They had services, so they had ways to traffic between, well, I'll get to it in a second. I'll show you. Okay, the next one I'm even going to do faster because these concepts are so specific to actually playing. I want to come back to them while we're doing the labs. Is that okay? So don't ask too many questions if you want to get your coffee card. Talked about that. This is some of the stuff. In the early versions of Kubernetes, you did not have users and groups. Once you got into a Kubernetes cluster, you could see every namespace inside the cluster. We originally put in the users and groups, and some of that work has been pushed upstream into Kubernetes. Right? It's still not at the same level of the users and groups in OpenShift. So that's part of the reason why we're not using straight up. There's a bunch of things which we've pushed upstream that are not fully pushed upstream yet because of negotiating with communities. So we're not adopting them yet. Right? So like one thing is ingress, which you'll see in a second is our routing layer. We're not using ingress yet because it's not fully pushed up. Okay, the big thing I want you to get from this one is users and groups and authentication. That's pluggable. Kubernetes has a namespace. This is basically your sandbox where you're going to play around. We do a materialized view of a namespace based on the users and groups, and that is your project. So a project, which you're going to start right away, is where you're going to put all your stuff. In general, it maps to an application, but not always. We good with that? Okay. We're going to go through each of these pieces, so I'm not going to go to them quickly. Pods. Services handles communication between pods, sets of pods. So between your database and your web server, they're going to talk through services. Routes is how you manage stuff coming in directly to your pod. So something from the outside world. Make sense? Okay. We provide a software-defined network out of the box. Kubernetes requires a software-defined network. This is one of the things people hate setting up with Kubernetes. We give you one straight out of the box. It's based on Open vSwitch. It is a good reference implementation. If you have very complicated or big needs, it is probably not what you're going to do. And you're going to probably use one of the pluggable providers from like F5, right? Who's the other ones that we support? Cisco. I don't know. There's a Nuage. This is pluggable. Almost everything we do is pluggable in here. Okay, there's the data stuff that I was talking about before. Persistent volumes, which is where you say I want some space available to me, and then the claim is when the pod actually says, give me that space. I need this much space. Okay? So this is all, we'll cover this later. Replication control is to say how many pods should be up and running in the world. We think that people, when they write applications, want more than that. There's Kubernetes now has a deployment, which is based off our deployment configs, but it doesn't have all the same features that we have yet, so we haven't switched fully to deployments. Right? So we have a deployment config, Kubernetes has a deployment. This handles like how many pods to set out, how many pods to set up, what Docker registry to look to, where am I getting the Docker image from, when I update, do I do a rolling, do I do an up and down deployment? It handles everything about deploying your Docker containers. And we also handle builds. So we'll go over all this stuff later, and we'll probably come back to this pictures later as we do it. Sound good? Okay. That's it for slides.
Oh gosh, finally. Jeez.
You see how my teams work here? Let's see, I got harassed by who? Mikhail. I got harassed by Jorge. Graham was going to stand up and interrupt me. I have an international crew of a crew of international interrupters and sass givers. Any questions before we get on to the workshop? Is it hot for everybody else in here, or is it just me?
Just you.
USB stick? Does everybody have the OC client tools who has a laptop?
Who wants to do the lab?
Who wants to do the lab? You have it? He sits next to you, you gave it to him. All right.
Can we also do it with the web console?
Yes.
Because I hate command line.
Yes.
You know, the funny part is that I also really relate to you. Like, if you ask my team, one of the favorite things coming out of my mouth is, I hate, and then Grant gets anxious because I say that word. So that's it. For those of you who want to watch, Grant will be doing all the lab exercises, but they'll also be...
I was okay.
Well, you'll be doing them you're not going to do them as we go along?
Yeah, I can do it.
Okay. I like to do them after everybody's had time to do it so that we can talk about it.
Sounds good.
But you'll probably be bored for large chunks of time while we let people do what they need to do. Okay?
Okay, so let's go back to one of his previous slides. Right here. I'm going to leave this up just for a minute. This is the lab manual that we're going to be using today that we created for you guys. And so I'm just going to stand here for like 30 seconds while everyone gets this pulled up in your browser, okay? Now, the environment we're going to be using is running on Google Compute Engine. Is that what they're calling it now? Google GCP, Google Cloud Platform, Google Compute Engine. It's running on Google's cloud. It's not on AWS. It's not on Azure. This would work the same on either of those platforms. We have spun up a machine for us to use. Everyone is going to be using the same cluster. We created user accounts for everyone. What I'm asking you to do is just use your user account. You will know the username and password for everyone else's account, but please don't mess with other people's stuff. Just be a good citizen and not hack into other people's stuff, okay? It's not fair to them. They're trying to work. So what we're going to do is I am just going to point to you, and I'm going to tell you your username and your password. I have a big brain. I know what they all are. All right, you are going to be user 1, and your password is user 1. See how this works? Okay.
It's user 01.
User 01. Okay. You're going to be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 in the red, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31 in the gray shirt, 32. Okay? So I'm going...
Don't worry if you're not using it and we gave you a password. We made 75 of them.
Yeah.
We made 100 accounts? Shh.
Okay.
Now there's going to be Bitcoiners taking all the rest of the empty space.
So this is the lab manual. Let me make this bigger. So everybody works at different speeds, but I will be showing these labs for those who don't have a laptop and still want to see it. But please work at your own pace. Don't try to keep up with me, and I'm not going to try to keep up with you. The technologies we're going to be using today are Docker images that we've built. we're going to be creating new Docker images using the Python language. I used to use Java, but we switched to Python, mainly because we have Graham on the team now. And Graham wrote the mod WSGI Python server, and so he's forcing us to use Python a lot more now. Okay, so let's go ahead. I'm going to show you how to do. The first lab is just to install the OC client tool. And Steve gave you these on a USB drive. But if you didn't have that, I also provide links in here with instructions. You basically want to unzip the file and then add it to your path. Whoa, gosh. So at the end, you should be able to type OC version. And I am running an older version of the client tools. I'm running version 1.3. You're going to be running the latest, 1.4.1, I think. And then once you log in, you'll see the Kubernetes and OpenShift version. So that's lab 1. Okay, so I'm going to give everybody 5 minutes just to get this running on their local machine. And again, if you work faster, just keep plowing through the material. And at any point in time, no matter where you're at in the workshop and you are stuck or have a question, just raise your hand and one of us will come and help you solve your problem to get you back up and running or to answer your question, okay? But as a group, as a class, I am going to be setting times on things and showing it as we go along, okay? So let's go ahead and get started on the labs, lab 1. Pardon?
It's okay to use an older version.
It is okay to use an older version. I wouldn't use a version older than 1.3 or 3.3. It'll probably still work even if you're using like 1.2, but yeah, it should be fine.
It seems to be not working on my favorite Windows version.
Okay.
Windows XP.
On what?
It's not working on Windows XP.
Oh, yeah.
Are you running a 64-bit version or 32-bit?
32-bit.
Yeah, you're out of luck.
That's
We use the web interface.
Yeah, use the web interface.
And complain to Clayton. But you're not going to get
Is
very
that- Yeah, is it matching? Yeah, I have the. Well, yeah, I have the smaller version. Do you have the 970 or 980 video? Yeah. Yeah.
Hey, for everybody, I know I'm interrupting one more time, but tomorrow, what time, Graham? Tomorrow I have the last talk of the day, which I know you're all going to be excited for. Graham's going to be going in, we're going to cover readiness checks and liveness checks very shallowly here. Graham is going to actually address the question about databases and web services and readiness checks in his talk tomorrow in the last session. Okay? So look for Graham Dumpleton, OpenShift talk, if you really want to dive in on readiness checks.
And I always make this comment, and I'll make it again on this first lab when you add something to your path, because I always think it's funny. On Linux and OS X, you just export a path in your new path. I provide instructions for Windows because Microsoft considers changing your path by going into System Settings and then Advanced Settings. So changing your path is considered advanced.
So it's actually the Windows stuff is 64-bit, so it doesn't work. It's not limited to Windows XP.
It's just the version of your operating system, yeah. I mean, we could build 32-bit clients.
Yeah, because I've got loads of virtual machines in my computer, but they're all 32-bits.
Yeah. Yeah, if your host OS is 32-bit, your VMs are going to be 32-bit as well. Okay, I'm going to go ahead and show the next lab. So in Lab 2, we're going to be exploring the command line and the web console. If you don't have the command line, you're just going to do the web console. If you have problems logging in, this is the most critical thing. To do this, you want to do OC login, HTTPS, console.devconf.pixie.io, port 8443. Now, if you're on Windows, if this is the first time, it's going to ask you to accept the security certificate. Just say yes there. It's a self-signed certificate. We just didn't purchase one. And then you're going to log in with your user. So user 01 or user whatever. I'm just going to use 50. Then your password is 50. Okay?
There's a mistake in the
Oh, good.
documentation. It's written PIXI while you have used PIXY.
Okay, so they found a mistake in the documentation. So let's fix that real quick. And it's in the first lab. And explore. Oh, PIXI. It's Y. So let me change that real quick. Explore.
By the way, what's the password? Because it's like user.
Same as yours. Yeah.
No, he just said he had. You were talking while he was just saying that you had to correct it, Graham.
So someone found a error in the documentation. It was PIXI. So I'm just going to kick off a new build to fix that. And so that'll be fixed in just a second. Just refresh your page. It's fixed.
Did you fix the documentation?
Yeah, I fixed the documentation.
Confirmed. Yep.
And the way I fixed the documentation, just while you guys are working, is I actually built a new Docker image on the fly and deployed it out. That's how quickly I was able to do something like that with OpenShift. That's why I love using it. And I did a rolling deployment too, so you shouldn't have experienced downtime while I was fixing the documentation.
Would you like to scale up the pod so that everybody gets his own web server for
Fine.
documentation?
We'll add 5 documentation servers so it's all load balanced. There, it's coming up. There, now it's load balanced.
So we need to have that performance boost in the documentation.
Yeah. All right, so back to the... So the most critical part of that next lab is to make sure you can log in on the command line as well as log in on the web console. So I need to log into the web console. So to do that, I'm going to go https console.devconf.pixie.io 8443. And I'm user 50. So I'm going to log in as user... Nope, I'm already logged in. Let me log out and log back in. User 50, my password is user 50. Does anyone need help logging in? Is everyone able to log in?
Who is not able to log in?
Yeah, that's a better way of asking it.
If
Okay.
you have a laptop and you're trying to log in.
Graham and Steve will help you. While they're helping you log in, I do need everyone to kind of take a break for a second. because I need to explain the application that we're going to be building today. Okay, we're going to be building a microservices-based geospatial application. Okay, so what we're going to be building is a map application that's going to indicate on the map a couple of things. We're going to start with a backend, a microservices backend that will display all the national parks in the world. The front end of that is written in JavaScript using Leaflet.js and just plain old HTML. And we're going to pull that down as a Docker image that we have built for this workshop. So just to show how you can deploy something from Docker Hub. Once we get that deployed, we're going to add a back-end system to it that's a microservices approach that has an API that's going to provide the national parks. And that we're going to build a Docker image from source code. Okay. And at the very end, we're going to add another microservices backend that will also map Major League Baseball stadiums. If you don't like baseball, Graham has written one for Australian Dunnies that you can use. We have a backend for flight information. And I believe we also have a backend for weather data. Is that right? Airports, something like that. And it's self-discovery using Kubernetes. And so we're going to learn how to apply labels to microservices backend that our front end will watch for and automatically display them on the map. So that's really what we're building today. We're using geospatial 2D box map queries to display that on the map. Who does not have a GitHub account? Okay. One of the things we're going to be looking at today is how to change the application code. And so to do that in the lab, I ask you to fork one of the projects into your own GitHub account. When you get to that point, if you don't know how to do that, just raise your hand and we'll come and show you how to fork a project in GitHub. Because we want you to have this code in your own account so you can make changes and then deploy it and see some of the automated deployment flows we have, okay? I realize some people may not have a GitHub account, may never have heard of GitHub. So just when you get to the deploying the Python lab, just raise your hand and we'll come and help you get a GitHub account and show you how to do this, okay? All right, so that's the app. So I'm going to go ahead and show you the next lab, lab 4. But it is important to read these labs. Like we have 2 hours. So if you really want to learn, actually take the time to read it. And I'll shut up in just a second so I'm not interrupting your reading after I deploy the first Docker image. And I'm just going to show you how this works. And you're going to actually read the lab. So in OpenShift, we support the ability to create Docker images on the fly or to use one that's in the hub. Now this is also important. As you're going through the lab manual, you'll see user XXX in all of the URLs, in all of the examples. Replace XXX with your username in every instance. So if I make this bigger, in the labs it says to create a new project called user XXX-parks. Because I am user 50, my project's going to be called user 50-parks. Okay? And I'm just going to click on create. Now I have a project and I'm going to click on deploy image. This is where you can actually deploy an existing Docker image from a registry. So I'm just going to click on image name here, paste this in. This is in the lab. And I'm going to hit enter. And it's going to pull down metadata from that Docker image from Docker Hub. And I'm going to click on create. Okay, so that's the next lab. So I'm going to give everybody probably 20 minutes to get to this point. Okay, but if you get to this point, just keep going. Work at your own pace. Okay, but it'll be 20 minutes before I show the next thing on the screen so you can actually concentrate and read. Yes? So go back to the lab. now you go back to the web. You log in on the web. You go down. And then lab. And then just go to the lab. Yes. OC space new dash project. It's in the lab. No. Go to the. So I was asked the question if I could explain, when I deployed an image, what that actually means. So if you're not familiar with Docker, the way Docker works is you have a Docker file, and a Docker file is almost like it's a descriptive language that defines what your image should look like. So if I wanted to install Tomcat, for example, an example of a Docker file would be from CentOS 7. Okay, that would be my base image. And then I would have yum install Tomcat, and it would install Tomcat. And then I would say cp my war file into Tomcat /standalone/deployments, for example. Okay, that's kind of defining what my image should look like. And then I run what's called a Docker build, and I pass in my Docker file, and then Docker creates a image based off of the commands that I have in my Docker file. And I gave you a very simple example that probably wouldn't work, but they can get pretty complicated. Docker, when you run a Docker build, it creates an image. So you have a image of what a running container should look like. Okay? You then take that image and you push it or you add it to a Docker registry. Okay? So you upload this big image to a registry. When you do an image pull, like we did from image, you pass it the image name that you want to deploy. It downloads that image, and then it runs it. It actually puts it into an executable state, and that's where you have a Docker container. Okay, so an image is like a snapshot of what your container should look like when it's running, and then a container is a running implementation of the image. Does that make sense? So you have one image, but you could have 12 or 1,200 containers running that image. And so what we're doing in this lab is taking an image from Docker Hub that someone wrote a Docker file for, ran a Docker build, uploaded the image, and we're running it or executing it as a container inside of a Kubernetes pod. Okay?
And two questions.
Yeah.
How large is the Docker image?
A Docker image can be very small up to very large, depending on what your Docker file does. I believe Graham's Python image that we're using is 17 megs. Is that right? Something like that? Maybe larger? No idea? Still a few hundred megs. When I created a Wildfly Docker image the other day with a full JDK 1.8 stack, and it was like 300 megs.
Okay, so it's got the files that you want to sort of install.
Yes.
And it's got the prescription.
Yes.
Okay.
Yeah. And so there's two ways to run images on OpenShift. One is just to run a Docker image that you've already copied all of your files into. But once you do that, you can't change them, right? Later in the lab, we're going to look at a project that's specific to OpenShift that we call source to image, that actually builds a Docker image on the fly based on your source code. And we'll talk about that when we get to that lab. But that's how I prefer to do things, is with source to image. But a lot of times you just want to run an application that's already pre-configured, like WordPress or Subsonic if you want to stream music, or whatever the case may be, Joomla or whatever, and you can find a Docker image for it. You can just run that as the image. Okay.
And the second question was, so if the image has got like a couple of hundred megs, then do I understand it that the Docker Hub is actually hosted somewhere by someone? It has to occupy a large...
Yes. Docker Hub, the public Docker Hub, is actually hosted by Docker Inc., the company behind Docker. And yes, they do probably have massive amounts of storage. Well, so not really, because it's a layered thing, right? And so if my image is 600 megs, Docker, because I did from CentOS in my simple example, CentOS is stored as a layer, and everything I do on top of that is just an additive layer. So my actual image is just
the Wildfly and the JDK stuff.
Yeah.
Good.
So it's all additive.
And when we sort of downloaded the image to this instance of the virtual machine, does it mean that the Google the Google computer somewhere downloaded those?
Yep, so when I deployed an image, what actually happened is my OpenShift server, which is running in Google Compute Engine, connected to Docker Hub, downloaded that image, and stored it in the OpenShift registry. So now it's local to me, and I can use it as much as I want without it having to re-download everything.
Okay, so that's why it was so quick.
Yes. It was quick because I did it last night, and so it was already cached. Yeah?
I have a question, please. Did OpenShift support GitLab?
Yes, of course. Yeah, we love GitLab. In fact, our standard workshop uses GitLab, and I had to rewrite it last night to use GitHub. So, yes, it works with GitLab just fine.
And Bitbucket if you...
And Bitbucket or whatever.
Well, we actually, for GitLab, what Grant was saying is that we use GitLab, is that we work, actually, Jorge, or one of the other advocates, worked very closely with the GitLab people to actually make proper Docker containers so that we can actually spin up GitLab in OpenShift. So in the normal workshop, everybody has their own GitLab instance, and they're working against that Git repo and doing stuff. What? Is that true or no? Am I saying another lie? Oh, one lie? Yeah? One instance? Oh, there's only one instance that we usually use? And everybody shares it?
You've got a repo for everybody. Everybody gets their own repo.
Okay, so I lied. There's in the mask. Are you Czech also? No. You're Greek. Maybe my rule is really just anybody that's not me likes to pick on me. So right, we send up one for the whole instance, and then everybody uses that. Sorry.
And the reason you don't have the GitLab for today is because I was lazy to deploy.
So wait, can I just say one more thing for especially the people who haven't used Docker before? Can you go to the console?
The web or?
The web console?
Yeah.
And so we're using a Is this Apache? What did you put your source code in? What's the web server in?
Mod whiskey.
It's another Python one just to do the content too? Okay, so can you click up?
I already showed this.
You already showed this? So everybody knows that this is scaling. But what I want people to visualize while this is happening is if you were using VMs. So if you said, oh my gosh, I've got so much web traffic, I need to bring up another server. How long would it have taken to go to 2 VMs?
20 seconds.
5 seconds?
20 seconds.
At least, because you have to boot the whole OS. Then you've got to wait for it's got to do its whole boot up. Then it's got to boot the web server. And then you've got to plug it in. So this is back to why, okay, so Merrick says they're not immutable, but they are compiled, right? So what you're actually doing here is you're not booting a whole VM, you're spinning up a binary. Right? That's already on the machine. So this is part, and we're not spinning up all the pieces of the operating system again. We're just spinning up the stuff we need to make another one of these instances. And this is what's awesome about, one of the things that's awesome about containers. Right? And this is also the stuff about configuring, everything needed to run that image is already in that image. Right? Which is, if we were doing this with RPMs, then we'd have to run some sort of other script to move the content in there and do all that other stuff. Yeah?
Instead of Docker Hub, if I have an image locally, can I
Yes.
use that?
Yes. And then the other thing is Red Hat has a registry as well. access.redhat.com. I think, is it access.registry.redhat.com? Yeah. So for some of you who are using like the Red Hat image, if you're a customer, you'll be pulling from that registry instead. Oh, we have stickers if anybody wants them.
Yes,
Steve, understood that you're reading the tickets for the questions?
Oh yeah, but there's so many questions.
Steve.
But
He has a Apache. 17 net.
Is what?
MSI.
I don't know.
The Chroma keyboard.
Okay, so here, I'll give you a coffee card for your laptop.
Oh, cool. Awesome.
Thank you. Thank you. Is there one for everybody? How many people do we have?
What do you mean?
Who are?
You don't have tickets for questions.
I know, we're here. So everybody can get a coffee. Everybody gets a coffee. You get a coffee card, and you get a coffee card. Who wants a coffee? Who doesn't want a coffee card? Okay, that's easier. Yeah, you can use it for hot chocolate also. Okay, now you want it? No? Too late. Here, I'll work my way down. Maybe you can get one. 1, 2. I think I have enough for everybody. We'll find out. Otherwise, it's going to be like battle. All right.
There was more people that wanted them, obviously.
Actually, no one's going to get. No one's getting more than one because I think I'm about to run out. I shouldn't have promised one to everybody. Mark, do we have any more?
No.
I guess I'm going to be going buying some and expensing them. Who didn't get one yet that wanted one? Everybody?
Steve?
Yeah. Oh yeah, you got it. Okay. Mark has no more though. You did not see what just happened. Mark, can you hand out just to make sure that the people who wanted them get them too? Thank you. Can you have 2 down? One more down. You got one already? You guys one? Sorry. At the end, okay? So you got one already? Great. See, even if you don't learn anything, you got a free coffee out of sitting here for 3 hours and listening to us.
Is it really true that OpenShift loves Java?
Oh, that's coffee.
I know about that.
Mark thought that was a good symbol for coffee.
Yeah,
Yes.
seriously.
Yes, we do.
What is up is still logging OpenShift REST API access.today.
Yeah, so you need to do did you do the permissions lab? Yeah, there's a permissions lab that you have to do.
Isn't Java too heavy for container?
No, it actually works great.
And okay, so now I
I
can
can
say
show
one
you.
more thing, because I like to make people appreciate what they actually just did. So suppose you started with a fresh Linux box. How long would it have taken you to actually get ModWhiskey installed, hook it up appropriately so that it's serving web content up, make all the security patches, do all that? How long would that have taken you to do? days. And for me as a developer, I know I would have done it wrong. Okay? Because I can do the systems administrator, but I'm always afraid like I'm the next, 7 million passwords exposed on the internet. So the nice part about this is someone who actually knows how to set this stuff up, set up the image, and all I had to do is run one command and I've got a web server serving up content. So
If you want to use Java instead of Python,
oh my god.
we have
I'm
labs
never
for
teaching a
that.
workshop with you guys.
We have labs for that. It's the exact same process. It's just a little bit slower for the initial build because it doesn't Maven build.
Okay.
It's only time different. Yeah, but the scaling is just as fast.
So it's hanging around until Kubernetes goes, that's taken too long to shut down. I'm going to force kill it.
Thank you for that detail that no one really needed. But it was good.
Okay, so I'm going to show the next thing, and I realize most of you are ahead of me, but that's fine. So once I have this Docker image deployed, in Kubernetes, I have a couple of objects right now. I have a pod, and I also have a service. I have some more, but those are the two that is important to me right now. The pod is the running container of the Docker image, and then a service, if you remember what Steve was talking about, is a internal mechanism to Kubernetes to know how to talk within the cluster. It's not a service in that it's not a web service. You can think of a Kubernetes service more like a load balancer to route traffic internally to the cluster. But what's missing from this is that we have a running pod and a running container. So we have the service right here. But it's not accessible yet to the outside internet. You haven't been able to look at your application in a web browser, for example. And that's because we need to expose that Kubernetes internal load balancer or internal service to the external world. Okay? And that's what we call a route. And this is also similar to the ingress concept in Kubernetes that you may or may not have heard about. But in OpenShift, we have a special implementation called a route. And so what I need to do is expose this service as a route. So you can do that one of two ways. In the web console, up in the top right, you can say create route, and you can give your route a name. If you wanted it on a specific host name, like your company was called ABC, you could say, I want this at www.abc.com, as long as you own that host name and set up the DNS records and all that stuff. If you wanted it at www.abc.com/myapp, you would put the path as my app, and it would, route at that context. Does that make sense? And then if you want a secure route, so you want an SSL cert, you can set that up, upload your cert, do all of that stuff. So if I click create, it's just going to create a default route. That's how you do it on the web console. On the command line, what you would want to do is do OC. Let me make sure I'm in the right project. Okay, so I'm going to switch to the user 50 parks, even though I'm probably already in that project. And now I'm going to look at the Kubernetes services. So I'm going to do OC get services. And I have a service called parksmap.-pi because this is a Python image, so I just named it -pi. And if I do OC get routes, I can look and see what routes I have. I don't have any right now. So I could either click that create button down here to create a route, or I could do it on the command line with OC expose service. I want to expose a service as a publicly to the public internet, and I want to expose the parksmap.-pi service. If I wanted to specify a host name, I can add some flags, but I'm not going to. I'm just going to let it default. And that's going to create a route for me. So now if I do OC get routes, I have a route, and it used the default configuration for my OpenShift cluster that I set up when I installed it to specify where my apps should live. And then the way this actually works, if I go back into the web console and go back to my app here, you can see that, let me refresh, did I?
You got it. You don't have to.
Oh, okay. Here is my route. I clicked refresh, and it was doing an AJAX call, apparently, to load it in. But the way what was I going to say?
You click on that link.
Yeah.
You're talking about how it knows to route to what?
Oh, yeah, okay. So the way it builds this URL by default is it takes my service name or my project name, it's actually the service name, parksmap.-pi. It then appends my namespace, which is user50-parks, which is my project, and then it adds .apps.devconf.pixie.io. That's just because that's the way I configured the server. Does that make sense? Okay. And so the way this actually works is everything is coming in, and then it's based on the HTTP headers to determine which internal service to route to. And that's probably getting too much into the networking side of things, but that's how it actually works. Okay. And so if I click this, and if you click yours, you should see, as soon as it loads here, I'm on the conference Wi-Fi just like you, so I feel your pain. But it'll load the map application in a HTML JavaScript style interface.
Does it also mean that you've got a DNS server in that?
Yeah, so the way it works, if we want to start talking about DNS, is you set up a wildcard DNS, okay?
Oh, okay.
So my DNS would point would point apps.devconf.pixie.io to the public IP address of my Google Compute Engine server that I spun up, and I would do a wildcard DNS. So anything that goes to, xxx.xxx.xxx.whatever apps.devconf.pixie.io goes to the same server. And then based on the HTTP header information that I send along with the traffic, it knows where to route it appropriately. That's how you can have everything talking on port 80.
And you did it prior to this workshop, like yesterday or something?
Yeah, we set Gandhi is the DNS server.
No, it's just the DNS is hosted as a zone on Google.
Okay, so he did it on my personal server. So this is my personal server that I run at my house, and I have console.techdope.io, and I just set up a wildcard in my DNS wherever I purchased my host name from. Yes, yeah.
What about non-HTTP traffic? Something else than HTTP?
Oh, so the question is, what about non-HTTP traffic? I don't know the answer.
So you would set up what's called a host port. Is that right? Is it called a host port? Yeah. So back in this architect, can we go back to the slides again?
Yeah.
And then go back up to the whole one, the cluster. So what you say, it's a cluster command. You say you set up a host port, and what you say is this port goes to by default we only do 80 and 443. Okay. So for the routing layer, that's just 80 and 443 right now. There's been stuff in the works which is actually to handle any kind of routing, but right now it handles data. A host port says when something comes in, you actually take a port on every single node, and you say this belongs to that host port, and then what happens is you can route directly into that host port, but you also you have to use you have to use TLS termination or something like that if you want it to be secure, and it's complicated.
You do use host port to get this port open on every single node.
Yeah.
And you say this one node will have all these ports open to the internet to the firewall, so you can access them from outside.
Yes.
It's a hack.
It's a hack.
It's a super solution,
but
it's a workaround to get it working.
Right, but what that means is even if that pod is not on this node, that port is still open on this node.
Okay.
Does that make sense? It's not going to look and see. So can we go back to this? I just want to make one other point about the services, because we're covering services. So a service, the object of a service, now I want to talk about it a little bit more in depth. It's nothing but a proxy and a load balancer. Okay, it's actually a firewall rule that's on every single node. Okay? The pod IP addresses are not guaranteed to stay the same. If your pod goes down and comes back up, it can have a completely different IP. The IP of a service is guaranteed for the life of that service. Once that IP is assigned, as long as that service is there, it will retain that IP address. And so why this is important is one for routes, right? So that we want to be able to make sure that no matter how many pods are there, we're going to talk to the service, not directly to the pod. But the other reason this becomes important, and we'll see this later, is these pods could be a database pods. And you have a service in front of them. You don't want your web server talking directly to the database pods. right? Because they could go down, come up, they could get new IP addresses, they could be moved to other nodes, you may scale up. You don't want to have to keep telling the web, I don't even know how you would do that for a lot of them. So what instead is, when you're writing your app code between the different layers, you're talking to the service. You're not going to talk directly to the pods. If they're part of a cluster, the pods can talk directly over their IPs, right? So you're spinning up some clustered server, like you're spinning up Couchbase or something like that. They can use their IPs because they need to know directly talking to each other. But between layers in your architecture, you always go through a service. Does that make sense? So that's what a service is all about. And you also learned about routes.
Should be set in the route contract in case I have multiple infront.
Sorry, say that again?
If I have multiple infront, so I can route over multiple public keys. Should I set multiple IPs in the DNS server?
So I have no idea how to do that. This is why I like being a developer advocate and people who do networking. So Jorge, pay attention. And Mark, the question was, suppose I have multiple IPs. Multiple public IPs. How do I set that up for DNS?
I can route over to internals, so should I set the two IP addresses in the permission so it can go over to
I don't need permission. It's one of the few things I won't do.
So we do. This is more like we would watch it as a stream. Follow over here is more like a tail dash. Yeah, and so we have a locking system which is L fluency and Elasticsearch fluency and something like that. And so that is all kinds of stuff. Yeah, this is just
Ports that make it ports that are specified as a double. Ports during the service.
Yeah.
Specified as expose 80.
Yeah.
And only those ports specified as exposed in the dark file are turning to service. So you have something like something way you want to follow what you say. The dark file doesn't support that.
No, no, you won't.
You could do it. You could ask several ports or even say those are exposed.
The service is totally configurable. You can say, the service, like let's say your pod exposes 10 ports. You can be like, I only want to have a service for one of them. The others are just for internal communication. Then you can just expose that one port to the service. And the opposite way around, I don't know that it makes sense to expose a service port if the pod isn't listening on that port, but you could do it.
You like introspect the Docker file.
We do by default. We do, yes, we do by default, but you can also handwrite them and say, you can name them special things if you want. You can give the port's name and stuff.
Okay, so the next lab that I'm going to walk through is the role-based access lab. And this lab is important because the way that this application that we architected works. Yes, sir.
Before we begin, because I have to go.
Okay.
Is this tutorial going to be available even after the DevConf?
Yeah, the labs I will leave up at the same URL. The environment will not be up.
Okay.
You will spin up your own environment with OC cluster up or something.
Wait, point to your book.
Oh yeah, are you going to be here later today? Or you stop by our? We'll have some books later, some O'Reilly books.
But it's also available for free as a
That's
PDF.
right.
Book?
Yes, it's one of those.
I got it in Prague, so maybe.
Wait, how long ago?
This year, in March.
Was it blue?
Yeah.
Okay, then that's the book. So that book will teach you how to spin up a all-in-one Vagrant machine on your box, and you can do all these same things, except for, are you doing a GitHub hook?
Yes.
So you can't do the GitHub hook because you can't talk back to your Vagrant box. But other than that, all the rest of the stuff you can use this lab to do.
So.
I will come by and take one more. Just to make sure.
Yeah. So later today we will have this O'Reilly book that we can give you guys if you want, that me and Graham wrote, or you can download the ebook at this URL.
Can you maybe paste it on?
Okay, so the way we architected this application is that we have a front end that we deployed as a Docker image. That front end is going to self-discover back-end microservices that we add. The way it does self-discovery is we want to look at labels in Kubernetes. And so we're going to attach a label to our backends just to say that this is a backend. And so in order for our front-end application to actually read Kubernetes labels, if this makes sense, and it will when you do the lab, we need to grant permission to be able to do that. And so that's what the roles and permissions lab is. We're just giving view access into our project so we can look at the labels. You could also use this if you had another developer on your team and you wanted them to have access to your project to help you work on it. You could grant permission based on different users that way. So that's what we're doing in this lab, and I'll just run through it real quick. And I have the commands here. I'm not gonna read it. I'm just gonna show you how to do it. We basically want to add a policy with the -z command that allows my user to view this. So I'm just going to paste that in. And now my front-end application has access to read the Kubernetes labels for things deployed in my project. Okay? And so I'm going to move on and do the next one real quick, which is deploying Python code. So I'm going to take probably 5 minutes to talk through this, okay?
Just one question.
Yeah.
Can you do it somehow via the web console?
Yes, you can. On the web console, you would click, Graham will come and help you on this, but you can click on this membership management button here next to your project, and you can add permissions on that screen as well.
Thank you.
Yep. Oops. Okay, so now we have a front end deployed that you should have working in a web browser. Now we need to add a back end. The first back end we're going to add, and we're going to add 2 today, is a Python microservice that uses MongoDB. Okay, but we're going to build that from source code using the source to image project. So halfway through this lab, I provide a Git repository. Click on that link, and this opens it up in GitHub. I am logged in, so you will need to log into your GitHub account or create a GitHub account. You will then click this fork button over here on the right. When you get to this point, if you don't know how, I'll come and help you. Click on fork. It's going to ask you which account you want to fork it in. I have a lot of organizations I belong to. Just select yours. You'll probably just have one. Click that button, and I already have it forked. Maybe I don't. And this creates a copy. Oh, I copied it into a different organization. That's okay. This creates a copy of that project. We call this a fork in the open source world. It creates a copy of that in your account on GitHub. So then you can make changes to the source code. Okay? Once you add changes to the source code, you can submit, you've probably heard of a pull request. That's how you submit a pull request. You would fork the repo, make your code changes, and then once you have something that's beneficial to the upstream project that you forked, you can create a pull request, okay? But we're not going to create a pull request today. We're just going to modify the code and redeploy it. So now I have a copy of this project into my GitHub account, and I am going to clone this by copying the URL here that's displayed, go back into my OpenShift console, and I'm going to click on Add to Project. And we want to add a Python application to our project. So I'm going to select Python. And on the next page, we've changed the UI to allow you some more flexibility to choose which version of the specific runtime you actually want to use. So you can list all the versions that's currently supported. Let's go ahead and use the latest version. Click on Select. Give it a name. In the labs, it says name it National Parks. That's what I'm going to do. And then you paste in your Git repository URL. Make sure that this is the correct Git repository URL that you forked. okay? So it should be github.com/your username /nationalparks.py, and make sure it has the .git on the end. This is one of the biggest gotchas that most people who work with GitHub initially have. If I go back to my GitHub page, you would think this is my URL for my GitHub repository. It is not. This is the URL for the web interface to my project. The actual Git repository URL you get to by clicking clone or download, and it is this URL. It's basically the same, just with a .git on the end. Does that make sense? Okay. So once you get that, just click on Create. And what OpenShift is actually doing, okay, under the covers, if I look at the logs, is I selected a base image of Python 3.5, and then I provided a Git repository. So you can think of it as doing this. It is taking that base image and my source code, and it's kind of writing a Docker file on the fly using from Python 3.5. We spin up a separate Docker container, and we run that code through a build process. In Python, it's going to be a build to resolve dependencies. In Java, it would run a Maven build or a Gradle build. It will take the artifact of my source code build that happens in that build container, matches it up with my base image, and creates a new Docker image on the fly for me based on my source code. And then it creates that Docker image and pushes it to my OpenShift Docker registry. So I have that image in my registry, and then we're going to pull the image down and deploy it as a running container. All of that happens automatically. Okay, so you basically just provide source code, and like 20 seconds later, you have a running Docker container in a pod. Okay, so now it's pushing the layers, like Steve was talking about union file system. Each layer is a additive change, and so the first time you deploy a source to image project, it has to push all of the layers. So it does take, 30 seconds or so. The next time I do this, it's just going to push the changed layers, so it'll be very quick. Okay? And so it's almost done. And you will see these changing permissions errors. That's expected. Just ignore them. And then if you go back to your overview page, you will have a National Parks back-end service and a front-end service. After you do that, we are going to add a MongoDB database, link them together, and we'll circle back at that point. I'm going to give everybody 20 more minutes to do this, okay, to get to this point. If you have any problems at all, just raise your hand and I'll come and walk you through it. Yes?
Just a good question. So I just added the national park application. Basically, it's just doing some business things to dependencies and routes.
Yeah.
Okay, so just so we can see progress. So I should know the permission.
Yeah, so it's done.
Exactly.
Okay, so I don't have the permission set up because I can't run the push on the release. There's no workshop, there's no documentation how to do it. Okay. Is it possible to start
Full source.
for the
Yeah, you do it on the. Go back.
Can you go there?
Project. I don't know how to do it. I just saw that. Go back to the project. So I think where Grant showed it before. You gonna show it, right? No, I don't think you have to do it there either.
Okay, so resources.
Slow down. Resources. Did you get it?
Yeah. Resources. Membership.
Yeah.
Yeah, but this one is already admin. So it's project admin, and then you select the role, and then here, yes.
Slot please. So yes, I'm selecting the admin, edit membership.
Yeah, so just select add
Which
role.
one do we need to select?
So here, add another role. Select which role you want to add. So in this case, should be edit, but you don't have to add it to the user. You have to add it to the service account. I
Yeah.
think.
So for you, the first.
So you need to go to the service account. So don't editing. Sorry.
Okay, so service account.
Service account. What service account was this?
It,
Default.
it's whatever you guys are using to
Yeah, in the
look
lab.
up the service.
I think it's
Deployer, maybe.
no default.
Default.
Yeah,
I
this.
don't have the default one.
Yeah, it should be
He
here.
has to make one because he doesn't.
No, the default one should be.
I don't have the default.
You don't have any?
I do have a builder and I do have a
Deployer.
This one should be created by automatically and should appear automatically.
It's not there.
No. That was the issue we had last night, and I think we added the permissions one. Yeah.
But
Yeah, the permissions. Yeah.
He's not using
so
the
he
command.
wanted to do it for the console because we've got it in the.
You've got to add the
multi-
service account because he's not done the commercial. He doesn't. This is not there by default.
I haven't done anything.
I got it. I know. I'm explaining here. Don't worry. I got because. Give me. He cannot run any command line tools. So the command where we actually created that service account has not been executed yet. He needs to first create a service account, and then he needs to give the permissions.
No.
Very good, thank you.
Dude, him and him both do not have the service account. You want to argue with
And
reality?
that's probably a problem on the labs or on the platform.
No.
Those three service account comes by default whenever you create a project. Default service account should be always in the project.
Okay, then you need to file a
Instead
PR
of-
and then teach him how to do a service account.
Okay, I can show you how to do a service account, but that's a problem in the labs. Default service account should be there.
Then the lab deleted it?
I don't know, so we need to find what happened, but
Are you talking about the REST one?
about what?
Are you talking the one to get access to the REST APIs? The way that Marek set up this environment, they weren't created by default. That's why one of the modules
Okay,
is to run the.
so
command.
just create here a new service account, user whatever you have, with default as the name, and then you need to add the role as I think is view or edit.
Well, it's up there in the middle.
Yeah.
So, Jorge, I have a project that didn't do anything in default. It's not there by default.
Should be. So.
Okay, so it's a problem with OpenShift.
Yeah.
No, it's just how Marek set the environment up.
No, it's not. Oh, maybe it is.
It's in the.
Oh, it's, so it's merit scripted?
The
You see how our team meetings go? Do you want to come to them? There's like, we bring popcorn for all of you too. This is a typical team meeting. So then Marek's deployer doesn't create that account.
We can discuss this later.
I don't create anything, I just create the project.
When he does the roadshow, he has one of the scripts do create.
We'll discuss it.
No, there will be words.
This word, because you should know this.
I do need to know this for.
Okay, so
But it should be per project. And the project people create it themselves manually.
So did you not get to what you need to do?
Yeah,
You still haven't created a service account.
there's too many things at
Okay.
once.
Okay, so he still didn't help you. See, I'll come in and help you.
Thank you.
You're welcome. Who got you the coffee tickets? And who's going to help you? I don't know how to do it, so we'll do this together. Ready? So,
Velocities, service accounts, yes.
yeah, but I need to figure out how to make a new one. Can we not do that from the web interface? Ah, so this is what he's doing. So what he's making a new service account here. Do you see this?
Yeah.
So you need to do user, whatever your user, whatever dash parks slash. I'm going to make a new one that has, I'm going to try to see if it works for me too. User 50 dash parks, and I'm going to give it so that's saying that what namespace do we want to create this user in?
Slash, yeah.
Slash, and I'm going to say Steve.
Okay, yeah, I'm setting up the default, yes.
Yeah, but you're doing default. The role, it looks like the role is view.
View. It says select the project though.
Where?
Well, right where the cursor links.
This is where you are.
Right where this says select the project?
And
Oh, okay.
saying select the project.
So you choose user 50 parks. Actually, so then, wait, take it back. Take it back. Everybody else can ignore this if you did this. Just keep going. So what you should probably do here is Steve, or
Default, yeah.
yeah, or spell my name correctly, because that is an insult. Then pick user 50 parks,
Yes.
and then you pick view
View.
at the bottom,
Yes.
and then add.
Good.
And that should look like the one that I have up on the screen.
Yes, I do.
Okay, now The next step is, I think that's it. I think we're done.
Shall I not add the edit row now?
I don't think we need to, though.
Just the view one.
Just the view, because there's no other users. So that's you've now created a service account that has view and only view privileges.
Okay.
So does everybody feel like they understand service accounts? Just to make sure? No? Okay, well, not at a deep level. Do you see why I tell Graham just shush? Does everybody understand them at a very basic level? It's because I get a lot of questions about this before from developers or whatever. How do I actually automate things happening inside of OpenShift without a human doing it? Right? Like I want something to automatically happen and I don't want to have to log. You need to create a service account and then use that service account to do stuff. You have a problem? Okay. It's a bad idea. Intro lab. Get into service accounts.
Didn't have a choice then.
I know. All right. Yeah. You can have more than a quick question. You know what? Let's just because you already made the new thing though. Failed before. Go to the deployment. This one.
Yeah, no, they changed the life and builder image.
And then say deploy. Let's just force it. It may have failed too many times, and it says I'm giving up. And so you're saying I've changed stuff. Go deploy. Okay. So now back to the overview. Yeah, or you can use just the overview, and it should be forcing the deployment. That message won't go away until you click it. So you can. A few seconds ago, yeah. So let's click on it then. Let's see what the error is. Did it work for you now?
Yeah.
No, I'm talking.
Yeah, I'm still about redeploying the application.
Okay, so go to
reading it.
Nothing. So let's go to the logs. Eric, I don't know how to run your application. So it's missing the app.
No, technically you were on downloading it for a while.
Oh, really? Okay, we from the GitHub, right?
Yeah, you've used it wrong.
So I just copied and pasted this one.
Can I ask one more question to interrupt everybody? Does everybody understand the concept of labels and selectors now? Do you have this comes though? You're going to do something with it?
Yeah.
Oh, never mind. Then ignore me. What else did I think that's key. Where do we do that?
No, you need to go back to the labs.
It is.
I don't think we do it. You change labels?
Yeah, you have to.
Why?
Because that's how it picks up.
God, this is such a bad way of doing this.
No, not that one either. Where's the forking? That one. So no, so copy paste that. Because rather than we'll just fix
It's right here.
Go to build. Actions.
But I guess it is what it is. So I have the option to rewrite it myself. Or get him to fix it, right?
And not only that, because I don't like the way. I mean, they did the work, so I'm not complaining, but I don't like the way you actually have to load. You have to hit an endpoint to actually
Rather than
insert
delete the app,
It should just happen.
Yeah, it makes it sound like
It makes it very complicated.
Yeah. But then at the end,
You can do the whole thing, I know, but so just one other thing that I just need to say. Service accounts, this is actually a really advanced use case. So I've done a ton of development on OpenShift, and I've never touched a service account before. Okay? I don't want you to think that you normally have to go like make a service account and do all this stuff. The only reason it's because Jorge likes to show really exciting things. So this app in the end is very exciting to look at, but it doesn't show you what a typical development pattern is. In general, you are never going to touch a service account, okay? Unless you're doing something very advanced. Does that make sense? Because I think people are like, why this is, OpenShift development is so hard. This is not normally what you would do. Normally, what you would do is you would say, here's my source code, or here's my Docker image, now go run it. And that would work. You don't have to create any special accounts or anything like that, okay? I don't want you going home and being like, this is the worst. Why do I have service accounts and permissions, and how do I know which one to use, and do I have to do that in my app? So please don't think that, and I'll have words with Jorge later. I had word with you when you were making the workshop, and I told you this was too complicated. Yeah. And the thing is, he's Spanish, and I'm Northeast American Jew, and so the words will be loud, and a lot of discussion and handshaking, and then we'll hug at the end and kiss each other. Not this time. Hello, my name is Inigo Montoya. You killed my father? Prepare to die. Hello, my name is Jorge Morales. You dissed my app? Prepare to die. Does anybody need water? If you want water, raise your hand. 2 people. Okay. I was offering to get it for you. Actually, there's some right in the front. Pikachu. Who else? Sauce. You want one? Or do you have a question? You want to?
There was someone else who wanted the water, but I don't remember who it was. Who else raised their hand? Nobody? Okay. Do you want a coffee or anything? Way back. What do you want? Latte? Is it a 2 ticket or a 1 ticket? The team tiny. No, mid is a latte?
Yeah.
What am I going to get for myself?
Sonia said the white chocolate was really good.
I did the dark chocolate. Actually, the hot chocolate itself was delicious. But I'm going to bring 2 because I'm going to get a decaf mocha. A decaf cappuccino, and then they'll put hot chocolate in it. So you just want a
regular
latte?
Mid-size.
It's to buy bill. It created route, and when the name of the route came from, there was also like user, online user number was there, right?
So he asked a question that probably other people are wondering as well. If you notice, if you haven't got to this point, you will notice when you run a S2I build with the Python code, it automatically creates a route, whereas before we had to create one. Why is that? When you deploy a image from Docker Hub, we by default don't add a route just because we don't necessarily trust that the image you are pulling down from Docker Hub is legitimate. So we want to give you time to look at it and then manually expose it when you're ready. When you did the source to image, it did create a default route based on the configuration of the environment, which uses your user and your project name. If you want to change that, you would just delete that route or edit that route by clicking Applications, Routes in the web UI, and then adding the correct host name that you wanted.
So S2I it will be always created.
S2I it is always created, yes.
Steve, go back to the finance.
He went to get coffee.
default number. Because my application is on 88 in this case.
With S2I, in a Docker file, you have an expose and then a port, and when we build it, we always expose 8080. It's just the default.
So basically, in a build
Yeah, if you want to change it, so if I go to add to project, Java. When you start your source to image, you can click this, and you can even deselect to not create the route. You can give it that target port. You can change.
Oh, my battery's just run down so quick. I realised it's because I started off everything on the box off shit with some screenshots and shit. Would the boxes just appear out there suddenly, or?
The book. Merrick's can go get them.
Oh, he has to go get them.
Yeah.
Oh, it's up to -6.
Okay, it's been 20 minutes, and I actually timed it this time. So now what I'm going to do is add a database to our application. I'm going to add the MongoDB database. So I'm going to go to my web console. I'm going to go into my project. And I have two things in my project now. I have the front end, which we deployed from a Docker image, and this National Parks back end that we deployed from source code. So I want to add a MongoDB database, so I'm going to click Add to Project. And you can do this one of two ways. You can come down here and click on Data Stores to list all of the data stores, or you can just filter based on MongoDB. And we're going to use the MongoDB ephemeral data store for this, so I'm going to select that. And you can set a memory limit. You can give it some names. For the connection username, we're just going to use MongoDB for the password, MongoDB, and MongoDB, just to keep things easy. Okay? And then I am going to, you can select a version if you want a different version, but just use 3.2. And I'm going to click on Create. And so what's happening is it's downloading, it's pulling a MongoDB Docker image, and it's going to run it as a container inside of a Kubernetes pod. So at the end of this, we'll have three things. We'll have a MongoDB database, which is done. It's up and running. We'll have the back-end service and the front-end service. So now we need to link this MongoDB database to our back-end service, okay, so it can have its own. So you can do that one of two ways. You can click on Group Service, or you can click on this little chain icon to link things together. So I'm just going to click that. It's the same UI. You can then choose a service you want to link to this. I'm going to select MongoDB. and click OK. So now these two things are in the same project. Okay. The next thing we want to do is actually add the authentication environment variables to our backend service. So you can do that on the command line, which is what I provide in the labs. You can also do it via the web UI. And so just to mix it up, I'm going to show how to do it in the web UI. So I am going to click on Applications Deployments, and I'm going to modify the National Parks deployment. If you remember back when Steve was talking, you may have heard something about, the truth of what the deployment should look like, and the cluster fixes itself if it gets out of whack. So what we're going to do is modify that deployment config, or the configuration that defines the truth of my application deployment. Okay, so I'm going to click on Environment, and I'm going to add MongoDB user, and that's MongoDB. I'm going to add MongoDB password, and that's MongoDB. And I'm going to add MongoDB database, and that is MongoDB. So I'm going to do something. I'm going to do this really quick. What I'm going to do is click on Save and then quickly go to the overview, and you'll see that because I changed the truth, that the cluster is going to correct itself. Okay, so I'll do this pretty quickly. Click Save, go to Overview, and you can see that it's doing a rolling update of everything that's no longer valid. And in this case, it's just redeploying that National Parks application while setting the environment variables in the container before it starts, or while it's starting up. Okay, so now if I look inside of this container, so I'm just going to show you something that's not in the lab. I'm going to click on the actual pod. One of the things you can do is open up a terminal inside of the web UI. So I'm going to click on terminal, and now I am connected to that backend container via a terminal session. And if I do env grep for MongoDB, we can see that when I linked these two things together, when I grouped them, it added the port and the service host and the IP address, but it didn't add the credentials. And so that's when I set like MongoDB user as an environment variable. We can now see that they're set inside of the container. Okay, it redeployed them. Now, after we do that and we go back to our mapping application and hit refresh, nothing happened. Why? We still have a few other steps to do, and this is in the labs. So I'm going to look at this. So now we just have a database running. The next thing we have to do is actually load the schema. And that URL is here. This is a REST endpoint that will display all of the data in the database. Oops. Let me copy that again. I'll just walk you through this here. So this /ws/data/all will list all the information in the database, and there's nothing in there right now. So we need to load the geospatial data into the database. So to do that, there is another endpoint that is /ws/data.load. So I'm just going to go over here, and I'm going to call that load. And it said it inserted 2,740 records into the database. So now there's 274 national parks in the database. So I'm going to click back, and we're going to refresh this. This is all the data that's now loaded in the database. So
the web application actually had it somewhere built in, and it can
load its schema by itself.
Upload it to the database, and then it uses it from the database.
Yep.
Okay.
So now there's one last thing to do, because if we have data in the database, we have the back end deployed, we have the front end deployed. Let's refresh our map. And it still didn't work. Why is that? And this comes back to what Steve was saying. Generally, this would just work, but we've added service accounts in this lab that by default, it doesn't have permissions to see the labels in Kubernetes. So that's why we added the service account. So now I'm going to label my back end as being a back end. Okay, and then the front end will self-discover that. Is that way too complicated? Does it make sense though? Maybe if I do it, it'll make sense. Okay, so
again, this is not how you would normally build your app.
yeah.
You generally know all the backends that you want to use, and you just connect them and you just put them together.
So this is the command I'm running. And you can do this on the web UI as well. I'm going to run the OC label command on the National Parks route, okay? The route object. And I'm going to add a type value or name with a value of Parks Map backend, okay? That's all I'm doing. Hit enter there.
So in the web interface, you go to the route.
Yep. So
it'll say labels, and you put that label in there.
Yep. So I'm going to Applications Routes in the web UI. Click on National Parks. And is it annotations?
No, you have to go up to Actions. This is going to be painful. Edit. Maybe it'll be an edit. Try edit.
I think you have to actually edit the YAML.
Scroll down. Scroll down. Yeah, you're going to have to actually edit the YAML.
Yeah, but that's fine. You could also have done it when you deployed it.
We haven't shown editing the YAML yet.
Yeah.
Go back and show it just for a second, because this is actually, so this is important. Well, even for those of you not using the web UI, pay attention. Yeah, I'm talking to you, the blue shirt. I saw your heads down trying to finish before everybody else.
So here's the label I added.
Wait, can you say action edit YAML?
Yeah, but here's the label I added, so it is displayed in the web UI. And then if I edit the YAML inside.
Remember we said the truth? That's what the truth looks like for the route. Right, so when we set up the route, there's the host, so that's the URL that we're going to go to. And what is it pointing to? All the rest of this stuff is all metadata. It points to the service, National Parks. We actually have the ability to split the route between multiple services. So, but in this case, we're saying all of it goes to there. It's going to this port, and then it's defining truth. Right? So you could actually, if you wanted to, you could actually, rather than doing that whole web interface step or making OC expose, you could actually save this file on your machine and then resubmit it on a totally different cluster or the same cluster, and as long as that service was there, it would just work. Does that make sense? So you could actually spit out the configuration. There's a command line tool to do this. You can spit out this truth about your entire app project, move to a different machine, and as long as that machine can see the same Docker images or the same Git repos, you can just suck the truth back into that cluster, into the new project, and it'll basically spin it all up.
Okay. So here's the labels that you'll need to add if you're doing it via the web UI. Just add type and Parks Map back in. All right. So now I didn't even have to refresh. It just self-discovered. And now here are all the parks. And we're actually using a terminology called cluster grouping. So if I zoom out here and come to like where I live in eastern United States, there's 456 national parks. So if we weren't using cluster grouping, it would get out of control pretty quickly with all these blue points would be all over the map, right? Because there's a lot of national parks. But let's go back to over here in Europe, and we'll just take.
Does anybody do mapping stuff like this? Are you thinking? If anybody's thinking about doing mapping stuff like this, you remember how many points did we put into the database? 2,740, right? Putting 2,740 dots on the map basically makes the map unusable. And if you go much above that, also you're chewing up a lot of memory in the browser, and the browser starts to actually become unusable.
Yeah.
So the reason we did this is advanced visualization techniques.
Yeah.
So there are no public national parks in in the Czech Republic. A couple of them.
That's just as the data we loaded.
Yeah, again, blame Jorge for saying that was the official national parks.
Yeah, it's just the data we loaded. Like we did this ourselves. And so if you click on one, you can see the name. So the way this actually works, if you want to actually dig into this, it's very simple source code. The browser you can think of as like a box, right? And so the ends of the box has coordinates, longitude and latitude. And so every time that I zoom in or zoom out or drag the map, the coordinates change. And so we do a query, the back end does a query via a REST API. We pass in those coordinates. It does a 2D spatial query in MongoDB based on these 4 coordinates and say, give me everything within these bounds, and it gives us the longitude and latitude points back along with the name via JSON, and then we just pin it on the map. Okay, it's very, I know it sounds complicated. It is actually extremely simple to do something like that. And just look at the source code. So, and Steve originally wrote this app, and I know nothing about spatial stuff, and even I can do it. So it's like 20 lines of code.
Yeah, the JavaScript is like 5 lines of code.
Yeah, it's really easy to do this type of stuff.
So how are people's heads feeling? Are you over full? Or can you take in, I'd like to talk a little bit more about labels, because it's really important to understand labels in Kubernetes. Can I talk a little bit about it also? Sure. Okay, can I take the machine for a sec?
Yep.
So this is why labels are important, and it's going to reflect back on that whole truth thing, and this is going to tie a bunch of stuff together. So remember when we talked about services, and services front a certain number of a certain pod, right? How does it know which pods to actually route to? And so the way that actually happens is through a service and through labels and selectors. So if I go to services, right, this was our original Park Maps pie, right? And then that was our front end.
Yes.
Right? So that is the selector for that service. So that service says, anytime there is a pod that comes up with this label, I am going to route traffic to it. It doesn't know anything that's in it, doesn't care. It's just saying, anytime there is something with this label, I am going to route to it, and I'm going to route to port 8080. So whatever comes in, I'm going to route it in. Whatever comes into the service on port 8080, I'm going to send it to the port 8080 on the pod, no matter what it is, right? The same thing also, we didn't talk about deployment config. I talked a little bit about deployment configs. Did you go over, while I was getting the coffee, did you go over a deployment config?
I talked about it.
Okay. So if we go back to the deployment config for that Parks Map Pie, you'll see it also has selectors. Right? And this is, so it's saying, look, I have to have one replica up. That means I have to be able to find at least one pod that has these labels on them. Does that make sense? So Mikhail just came back. Mikhail, I have a question for you.
So it's not a pod, it's a replication controller with that labels.
I know, but we don't talk about replication controllers here because we hide them as OpenShift.
Okay.
Right? Now you just made my life harder. Do you remember back in my diagram where I said replication controllers and then above them there was the deployment config? Replication controllers, all they did was just say how many are supposed to be up. We think that we need more than that. Most people need more, so we wrap the replication controller with a deployment config. Mikhail, being the engineer, had to go into the low-level implementation of what that wrapping means, which is when I say this goes to 3, it then goes to the replication controller that it's wrapped and changes the 3 down there. But I was trying to not put so much information in your head because there's only so much information people can hold in one session.
You have 3 hours.
That doesn't matter. People's head only has so much space. Whether you have 3 hours or it has to be multiple days. So does everybody get, though, that this is basically saying it's looking for pods that have these labels? Now, I did have a question to you for Mikhail. If you put 2 labels here, does that mean it has to, both labels have to be on the pod?
Yes.
Okay. So this is like an and condition. It's not an or, which I never knew until, I was always confused about that, but now I know. So the pod actually has to have both those labels, otherwise it doesn't count. Now, this is where it gets, does everybody get what I've said so far? Are we good?
So in Kubernetes,
No, done. Shh, shh, shh.
So there's a replica set.
Shh, shh, shh. Okay, so everybody got what I've done so far? Thank you for listening to my shushing. Just because I don't want, yeah. Okay, so now I'm going to go back here, and I'm going to spin up multiple replicas. Did I click it? MSI makes very bad trackpads. Just tap. So where's Park X? Okay. So now I've got 3 replicas up, right? 3 pods running. So let's say we're starting to see error messages from one of these pods. Things have gone terribly wrong. Something's wrong in one of the pods. If you were running in a normal scenario, or you were running Docker containers, you'd actually have to take the Docker container down, and you would lose everything that was happening with it. We don't actually have to do that here. So what we can do, we'll go to the pods. We'll say this one, because it has too many letter T's in it, is the one that's causing problems. And we're going to go in, and we're going to edit the YAML. So remember, there's our labels for those pods. Right? So these are the two that the deployment config made. This is the one that's like, I'm this unique one. So I'm going to go say in here, and I'm going to say park maps. And I'm going to say, can I use caps? Capital letters? Okay. No. Oh, yeah. So we're saying that one's bad. I want to investigate this one. But I don't want to keep putting traffic to it because it's causing problems. So watch what happens here. If I go quickly to the overview, and I can scroll, I have to tap. I should just hook up a mouse. Okay? So if I go down here, no, it's too late. It was too fast. There's still 3 running. But if I go down here, there's a pod running all by itself, not connected to a deployment config. So because it no longer has actually we changed the wrong thing. It's still going to get routed to by the service. Why? Do you remember what the service selector was? It was based off the deployment, and I didn't change the deployment, did I? No. So that was the wrong way to do it. But let's pretend I had done it the right way. If I had done it the right way, and we scroll down to this, and actually change the deployment, these would still be running. A new one has been spun up. They're all doing what they need to do. This one is still up and running. No problem. It was having all the errors, but no traffic is being routed to it anymore, and it doesn't count as the replica. So this was part of that automatic self-healing, right? As soon as I changed that label, the truth of the world was there were still not 3 pods running with the label that it needed to see, right? So the deployment config said, the world doesn't match the truth. I'm going to fix that. And in terms of the routing, the service would have said, this pod is no longer matching the truth. I don't route to traffic to it anymore. And so how fast was that? Nobody had to do, all you had to do to make that change was just change a label. So one of the real powerful things about Kubernetes is selectors and labels, because it allows you to reconfigure your entire app on the fly, non-permanently also. Because all I have to do now to this one is edit the YAML again. Turns out it was a false alarm. It actually was good. I save. Go to overview. Tap. And you can see it's scaling down now. So it put that one back into the deployment config again, and it's getting rid of the most recent one. Saying, I've got too many. That doesn't match the world. I need to scale it back down. So the real point of me showing you this is how labels and selectors work and why they're really powerful in Kubernetes. Did everybody get that? That was the take home from it. So, yeah.
Completely different question, but the MongoDB, didn't you said before that the images are read-only? So how or where does the MongoDB store the data?
It's not read-only. It's the image itself is immutable. The container is not. Remember in that diagram, because you remember have you used AWS? Have you used EC2 on AWS?
Just OpenShift Online.
Oh, okay, then never mind. If you actually go into a running EC2 image, you can make changes and you can put files in there, but when you shut it down, those changes aren't persisted. So what's happening, if I go back to this one, when we look at Docker again, can you see that? The top level is a writable. So when you spin up the container, that's actually a writable layer. You can write and do all sorts of stuff inside of the container, as long as you don't exceed file space or whatever. But then as soon as you shut that container down, or if you spin up a new one, those changes will not be in the new one or when it comes back up.
In that case, can you stop the MongoDB then we will lose the data. Is it correct?
No. Well, it depends on how you. So remember when I was talking about persistent storage?
Mm-hmm.
So it depends on how when you spin up. So can you go to the deployment config for that? For Mongo? Here's the
mount.
So here's the mount. So this is, I think this one's using a, hey, Jorge or Merrick, this is using an empty dir, right? Yeah. So one of the mount types for Kubernetes is called what's called an empty dir, which means this data directory is going to be empty when I start, and I'm going to just grab it off the host volume. So that I'm going to grab some disk off the node.
Yep.
Right? So it does that. You put the data in there. That for an empty dir, that data persists as long as you don't delete the pod. So the pod can go back down and come back up. The data will still be there. I've done that on my own. I went into Docker and I killed the actual pod, and the data, when it came back up, it still saw its own data.
So essentially, if I understand it, you've got that folder is mapped from outside of the Docker container.
Yes. So this is basically saying we're going to mount a host volume called MongoDB data, and on the container, it's going to go to var lib MongoDB data. It's an empty dir.
You can try to add storage, like that will explain like the concept.
Oh, yeah.
So when we added MongoDB, we could have done it differently, meaning we have multiple versions of our database. So we have MongoDB ephemeral that uses the empty dir concept. So the storage goes away when you destroy the pod. Okay. We could have done MongoDB persistent, and that would have allowed me to delete the pod but keep my data around.
Because remember the persistent volumes and the persistent volume claims? This would make a persistent volume claim to something that will stay around. Make a persistent volume claim.
Right, right. But that would be like a different thing than just mapping to a file.
It'll still do the same thing under the hoods. So if we go back to the deployment config again, you'll see that there's down here, the volume, it'll say, I've mounted this PVC and I've mounted it at this place. And then you'll see, when you go back up to the specific mount that it does, then that'll point var lib MongoDB data will actually be pointing to whatever that PVC was mounted as.
Right.
Does that make sense?
Okay.
So it just depends on how much, what inside of the cluster for you and what for. If you really get into this and you start doing a lot of stuff with databases and you care about them being up, you're going to want to read about stateful sets. Okay, I'm not going to talk about them today.
Yeah, I have one follow-up question about slowing it down. So when I've got a web server and it logs things somewhere, where does it store it?
So it depends on where if you don't mount a directory, like if you don't make storage for it, it's going to write it into that writable layer in the pod.
So if I stop
the pod, it goes away.
Right.
Does that make sense?
But you should really be writing all the logs to std out.
Right. So wait, I was going to answer that question, and then the standard for Docker containers is to write to standard out. And
really?
Then yes, but I'll tell you why. Because what you want is a central log drain. Right? When you're running, like we're only running 3 containers here, or 4 containers. Suppose I had 50 Mongo containers and 100 Apache containers and 100 Python containers. It's impossible for you to actually go and read the logs in every single container, right? So if you put stuff to standard out, what happens is the framework grabs the stuff that's coming from standard out and drains it to, we have a built-in logging, but it could be something else that you plug in. It takes those and puts those into, in us, it's an ELK stack.
EFK.
ELK, ELK.
EFK.
Oh, EFK, we're using FluentD rather than Logstash?
Yeah.
Okay, it's an EFK. I don't know how to pronounce that. EFK, as opposed to ELK. Yeah.
You see it in the tab on the page. If you stream to std out, there's pod, logs.
Yeah, all right.
By default.
Yeah.
Even the login.
That's what shows up in these logs as well.
Yeah, I was. I saw the logs here, but I was thinking like this is not sustainable to have it on the web page. So that was.
But it is. But so what happens is this gets sent to the logging framework.
Yeah.
Right.
I didn't know that.
Yeah. That exactly. This would not make sense if there was no other place to put it except for small applications, right? Because you want to be able to search it and save it and do all that other stuff on it.
Yeah.
So. I mean, there's nothing to also stop you, though, from doing a PVC and then mounting and then put it, like in Java applications, you could say I'm doing with log4j and then define a logging output to that persistent PVC as well, the persistent volume claim.
Okay, there's one other thing I want to show you. We have 30 minutes left, and then I'll just not talk anymore, and then if you can leave as you finish, or you can just have quiet time to work, and we will help you finish the labs. And that is the point to where you all will hate us both, because we basically do everything we've done today in one command with all of these things, and that's called application templates. So we do support the concept of a template that once you get things running the way you want it to run, you can create a snapshot or a template of that, and then developers can just deploy a template and it brings everything up the way it's supposed to be. So that's useful if you had a development stack and you have someone new on your team, and instead of them spending time getting everything set up and their servers configured and their source code repositories to compile, they can just do it with one command. And so that's what we're going to do. We're just going to add another backend as a template. And so the templates are written in JSON or YAML. And so you can do this on the web or on the command line. On the command line, you would basically say OC create-F from file is what that stands for. But a file can also be a URL. And I'm just passing in a JSON template that defines the application. So now that I've created this template, it's now available for me to use, okay? And so if I go back to the web UI and I click Add to Project and I search, or if I go to Uncategorized, it should show up here, maybe is where it's at. Yep. MLB Parks. So it's added to the web console as well. So as an admin, you could add this template, and then the developer could just come in and click Select, and it would deploy, okay? So I'll just do that from here, and I can give it labels, but it's already, look at this, it's already going to have, these are the images it uses. Let's see.
Well, go back up. You just passed a whole bunch of stuff. Go back up. So it already has the database name, all that stuff already. Remember how you guys had to go in and set the environment variables for everything? It's already got those set, and it lets you change them if you want to.
Yep, and it'll have the labels. So if we wanted to do that on the command line, I just do OC new app, and I use the, let me clear this, paste it. OC new app, and I'm going to new app this MLB Parks-Pi. That's the name of the template that's available in the system now. I'm just specifying the application name, the get source code, and the reference. Hit enter. And it goes off and it creates everything, including the Mongo user accounts, links it up, and it deploys it. So if I go back to my web console and go to the overview page, we'll see it spinning up here. Down at the bottom, maybe. Here's MLB Parks. So it's waiting for the data, or it's the database is coming up. Once the database comes up, it will then deploy the app and marry them together, and then we'll reload the web UI in just a second once it gets finished deploying.
Is it doing a bit?
Yeah, I think so.
It should be doing a bit.
Yeah, so build's been running for 32 seconds. So let's look at the log so we can see when it's done here. And it's pushed in 5 of 10 layers. So this is the first time we've deployed this back in, so it has to push every single layer, right? Each layer is new. So if that's done, we go back to the overview page.
Did you talk through builds before?
Mm-hmm. So it's spinning this up, and it's waiting for it to become ready. We have a readiness probe, and if you're more interested in readiness probes and liveliness checks, Graham is giving a talk tomorrow on that that you can check out. So we're just waiting for that to say it's ready. So this is creating the database schema and everything for Major League Parks. Now it's ready, and it has that label. So if we go back to our map visualizer, and this polls every 15 seconds or something like that. So it'll show up here in a second.
It's polling. We can have a live watch, but I haven't implemented it yet.
So now we have two things we can display. We can display national parks or Major League Baseball stadiums. So let's say I don't want to look at national parks. I'll just deselect that. And here's all the Major League Baseball stadiums in the United States. Okay? And if we wanted to look at grayscale, and then maybe we don't want parks, we want national parks, you can switch between them like that with multiple microservice backends.
And it would actually have been possible to do all of this in one file, the entire application. And it's not just good for new devs, it's also good for moving from development to QA to prod, right? And all, does everyone understand why that would be? Right, the developer can build this like this, give them the template, say, hey QE, I'm done, here's the template. QE can take it, run it, they can change the resource amounts that they give to things, or maybe change the URLs, and then suck all that in, and it's running exactly as it was running for the dev, which is the key part. It's not like, oh, well, I set up Wildfly on my desktop like this, and I used my database like this, and I did this, and I used these passwords. It's the exact same environment. So there's not as much of that, I chucked it over the wall, and you guys have to figure out how to actually get it all wired together. Which is usually what happens, right? Like, oh, you didn't set up you're not connecting to Oracle the same way we're connecting to Oracle, and so we don't know how to connect up, and you have to go and fix it, blah, blah, back and forth. It's all parameterized and in there, and all they have to do is change the username and password because they're talking to the QE database, right, rather than the dev database. So.
Okay, so we'll let everyone finish the labs over the next 24 minutes and then just ask
questions. Is there any other questions, though? Because the thing is, you can do the labs if you want, but this is the only time you're going to have like the engineers and the advocates all in the room together. If you have any other questions about, like, is it always this complicated? Yeah, go.
So in this case, the app doesn't know that it's running on OpenShift. So my actual Python code is not talking to any OpenShift.
There is no need.
It's just labels on containers.
So that even your app doesn't, even your Python code doesn't need to know about that, which is why I'm sad that we did all this other work. But so, in general, that is why we have builders. Did we talk about the S2I builders? Mm-hmm. So, in general, what most people do, for those of you who are using Docker now, how do you actually build your Docker images with source code in them? You do a Docker build, right? Is that right?
Yeah.
Yeah? No? Or you're not using Docker. But that's a completely different build process than you were probably using before. Right? What the point is of the S2I is you just feed it source code in the way you're usually used to feeding it source code, and it produces a new Docker image that then gets deployed and just runs. So you can basically take most repos, if they're not talking to a database, right? Because then you have to put in environment variables and stuff. But if you're just running a normal code, you just feed that code in and it just runs and goes. There's nothing special. That's why I say you don't even actually have to know Docker to do this.
Yeah, but I would have to publish somewhere the source code.
No. Like, let's just find one. I'll show you. So if I go to my GitHub, and I'll just find a repo here.
Simple PHP.
Simple PHP. This is just PHP code, right? And this is the same for Java or Node.js. Like, there's nothing OpenShift in this. It's just PHP code.
I know. So,
yeah.
So one way is to upload everything to some somewhere, and then the OpenShift will pull it on its own and build it and everything.
The source code, right? The source code.
Yeah, the source code. Or the other way would be, how about if I want to deploy a binary build that I've already got?
Yeah.
Go.
So if when people talk about binary build, I assume you're talking about Java with a EAR file or a jar file or a WAR file. Yeah, so you would just deploy the binary. There's a special deployment type. You would put it in a deployments directory and then just specify the command to deploy a binary, and it uploads the binary.
Can
And then
I do that?
Yeah,
Yes.
you can say, I want this wildfly or this Tomcat
Yeah,
image,
that's exactly what I want.
and it's up and running, and then you see, is it OC build or OC new app or OC deploy? There's
It's
one of
OC.
the commands, and then you say -- binary, and
It's also start build. You can use a binary or you can point it to a local Git repository. You don't have to have it in GitHub. What will happen is that the start build will do a Git archive on the local and it will stream it to the builder. So you don't even need to have a Git repo out there. You can just use a local file and just.
Well, I'm talking about the situation. I don't even have Maven. I don't have anything. I
You
would
don't absolutely
do the simplest thing
Yeah,
ever.
you don't have to. You just need to have the Java source code, and then when you stream it to the builder that has a Maven, it will Beerville, and then it will spit out something.
So
But you're still expecting that I've got.
no, we're talking about a binary deploy, like you're just deploying the war
Yeah,
file.
I just want to.
Yeah,
I've
you
got
simply
the
take
war
it,
files.
put it in a container.
You put it in a directory called deployable,
Yep.
and then you just say OC, I don't know what the command is though, is it start build?
it's still,
New build and then start build.
yeah.
Yeah, you just define a build that's a binary type, and it'll upload it from your machine, put it into won't do the whole Maven thing on it, just put it into the deployables
Very
directory,
good.
and away you go.
The only caveat on binary builds is that because you're pushing it in, then you can't have that automatic redeploy when you do a change as if it is on GitHub and use webhooks.
I don't care
So
about that. That's
it
okay.
means, it means then what you would set up your Jenkins environment, or create pipelines as such that when it gets to the point of creating it, it would then issue the command to initiate the start build, and that would push it up.
Yeah, so the actual command is OC start build -- from dir equals, and then the directory where your war file is. And
Very
then
good.
send it up.
Any
No.
chance to have it in the web console?
It is. Oh no, the binary build is not in the web console. Sorry.
Because it hasn't done web console hasn't, or the web doesn't have your local directory to push it from.
No, but we do it. Wait, go back to. You can still do stuff from your local directory.
Hey, sorry, advocates, maybe you will have a look at the build pipeline stuff. I think you can realize all that stuff with the build pipeline, right?
All right. So here's the other thing that you can actually do. Actually, a lot of our customers do, because they don't want developers actually pushing anything to OpenShift. What they want is developers putting code into Jenkins. Jenkins does a whole bunch of checks and all that stuff. Then it makes a Docker file, and then it deploys to OpenShift. So we can actually support that entire. You can either build the pipeline in OpenShift, or you can put your Jenkins outside, and it will watch Jenkins and allow it to deploy into the integrated registry, and then the deployment cycle takes over and just deploys the whole thing. So that's another way that you could get around ever touching the developers don't even know that OpenShift is involved in the process. Right? They're just building Docker. They're just putting stuff into Jenkins. It builds the Docker image and deploys.
Is that what you're looking for?
No. I'm looking for the absolutely simplest thing. So I've got an IDE. I build a web application. I can deploy it locally to my Tomcat. I want to deploy it to OpenShift the same way.
So which IDE do you use?
Like
Eclipse?
IntelliJ IDEA.
I know everybody does. I do too. So we had integration for V2 with IntelliJ. We have to keep bugging them to do the integration for V3. In Eclipse, if you wanted to play with that, there's actually a plugin. So what you can do in Eclipse is you can just say, pick a deployment target and say, here's my code, deploy it to, make a project, deploy Tomcat, deploy it to OpenShift. So you don't even, it's all happening in your IDE if you want to do that as well. Does that make sense?
That's better. Yeah.
There's a bunch of other stuff we can show you. Do you want to just see other stuff now, or do you actually want to finish the exercise?
I'll show you something really cool. If you're doing an interpreted language, so not Java, but something like PHP or Node.js or some interpreted language. So I just deployed a PHP app that's not up yet. So let's wait for it to come up.
So, here's a quiz to see how much people were paying attention. Why is that URL there without there being a pod there? Did you notice how he has a URL? There was this just 2 seconds ago, this pod wasn't here. Why? How could that be? No, Graham. How does Kubernetes work?
Now you've got the route, so you...
Going down the wrong route. I'm just going to, no pun intended. You're going down the wrong route. Stop there. I don't want you to spend the energy on it. Why would there... what's happening when he does all those commands? What's he updating?
He's changing the truth.
He's changing the truth. So the truth is there's a route named this. That route gets created instantly. It doesn't require a pod. It actually probably requires the service. So first it waited until the service was created, then it created the route, and then it doesn't care. Right? That's why when he does the command line, when he did that template, it went, right? In old V2, we would have been sitting there waiting for everything to spin up. All it's doing when it does that command is updating the truth and then waiting for the cluster to take over.
Okay, so my PHP app is deployed. Here it is, and I actually want to use OpenShift for real development, and I don't want to git push, and because that's not my workflow. Developers don't make a change and then push it. They work on a feature over a day, get it to where they're not embarrassed to show their code, and then they push it to the Git repository, right? So how do you use this for daily development as an interpreted language developer? So here's the app, and it's awesome. So I want to start changing it. So the first thing I want to do is clone it to my local machine here. So I'm just going to make a directory called grant, cd into that directory, and then clone this repo. So now I have the repo on my local machine, and I'm going to open it up in my IDE or my code editor. And here is my code.
Oh, that's awesome.
Yeah, it's great code. So what we actually have is if I do OC get pods, and we'll see a lot of pods because I'm using the same project here.
You can grep it.
Yeah. And then I can OC rsync my current directory because I'm in my project directory with my grant php-1 8dr8m pod, this one, because it's running. And I want to send that to the opt app root source directory. I just happen to know that's the home directory where all source code lives. And then I want to -w to watch it. So this is going to start a, wait, what? Did I type it wrong?
Grant PHP -1.
Too many dashes.
Yeah, there's no.
Oh, yeah, okay.
And rsync doesn't necessarily have to be in the pod for this either. If rsync isn't available in the pod, it'll just use tar to stream it.
But it's not as good.
It's not as good. Thanks, Graham.
Okay, so now if I update my code in my IDE, and maybe we'll just remove a few lines and echo this lab is over, and I save that, I just hit Control S or File Save. If I go back to my web app here and refresh, assuming I didn't do anything wrong.
No, go to your console to make sure rsync first.
Oh yeah, it errored out because this is why I at the very beginning. You remember I said I'm using version 1.3 of the client, and we're using 1.4. So if I was using the correct version, then it would have just synced it over.
I forget what. So do you remember what Ben set it to? The sync interval? It's like 2 seconds, 3 seconds. Every 3 seconds, it basically does an rsync, and it just sits there doing it. And so you could do the same thing with your war file, right? You just you rsync where your deployables is to the deployables on the server. Every time you compile a new war file, it's going to set it up there, and it'll redeploy it, and you can just keep going.
This method is only suitable, because I wouldn't use that for war files, but this is only really suitable for scripting languages.
I use it for war files, and it's great.
Where you can put source code up, and you can just live reinterpret rather than having to recompile locally. So the other option you could have done is in your command line go OC start build grant PHP from dir dot, and that would have actually uploaded the source code, done a rebuild of the image from your local directory, and redeployed the image. And that
but that's, you don't want to do it.
Well, no, because that way means that if you've got things like Node with extra modules that need to be installed, or Python with extra modules installed, should change the requirements list, then it will build them all in.
So this is a great example of how every developer does it differently, and we can handle most use cases. This is the way I do it, not the way he does it, not the way he does it.
It is the way I do it too.
Oh, is it?
Yeah,
Okay.
because so the only 2 minutes. So the only thing, like what Graham said, is actually very true. But if you're building a war file, the dependencies are already in it, right? And for a PHP or Python developer, you actually have to do a build if you change your requirements.txt because you need to pull down new dependencies. Do you understand that? So the idea for the workflow with this is you would do this, do this, do this, do this, do this. Oh, I'm ready to commit this to GitHub and actually trigger a full build. Because the builds take a little while. That's not how you normally do development, right? So this is for the interim stuff when you don't have a full build.
With a wall file, though, if you ask is that it's not going to restart.
Yeah, it actually, so, okay, Python developer. Tomcat and Wildfly, if you set it to auto deploy, if you drop the war file in, it says, oh, I will redeploy that for you.
It does.
Exactly.
Time's up.
Yes.
So where should we why was
So what this is saying is on this route national park, add this.
Just the one. So if you're doing it this way, you don't need to.
What's happening is there is something that says it's saying, oh, there's a new thing with this label.
Yeah, so if you're gonna do rsync, you would scale it down to one line and just work with one line.
So what it's actually doing is
they have USB if you guys need to give anybody like client rules or anything. I don't know if you need that. Just the Wi-Fi kind of stuff.
Awesome. We definitely got that. 1.8 gigabyte images that we don't need to install.
Yeah, that's not gonna happen. You don't want to copy them on this and hand it around. So what we did is we loaded it on here and had people install it while one of us was going over slides.
Yeah, that's what we were thinking. We can put it on.
I can go to the sandbox and
Yeah, but you may not need to pull that many layers.
But that seemed to work for us.
Nice. Thank you.
And just,
what do you do, just dump into a tarball for
I believe these are formatted as XFS, so they're available for any operators. But we just had a tarball set. We gave it to them, but we were doing font tools.
Nice.
We just took Windows Linux and then set one guide. Okay. Just throw them on here and then have people pass them around. See, I think I got everything. Do you guys want to speak these and hand them out?
Yeah. Thank you. Steve gave me a few yesterday, but I think we'll get a lot of questions. So.
Okay.